Hello guys, welcome to the Wi-Fi Pen Testing Bootcamp session 1. Thanks for choosing Pentester Academy and thanks for being the part of Wi-Fi Bootcamp. This is our fifth iteration. So this is the fifth batch for this bootcamp. Before starting on the bootcamp, a little bit introduction. Uh, I'm very sure that most of you guys already know about this as my bio, my name, it's already there on the sign up page. But still, just a quick introduction. My name is Nishant. I work for Pentester Academy. I lead their R&D team. The main work that I do there, we create labs, we create training content for our trainings, right? We create courses. That's all that we do. Before joining them, I was working with an enterprise company which used to create these Wi-Fi access points, enterprise grade Wi-Fi access points, and WIPS sensors. So WIPS stand for Wi-Fi Intrusion Prevention System. So they had a state-of-art WIPS, which you use to monitor your airspace. When it comes to Wi-Fi, uh, you are able to tag the devices using that. You are able to identify if someone is, launching some kind of attacks using it. I have a master's degree in infosec, and for past few years I have been presenting my research in different conferences. I have been conducting trainings at Black Hat, HITB, and all the other venues. uh, you already know about us. We are Pentester Academy. We run pentesteraacademy.com, which is a subscription based service where you get access to all the courses that we have and all the labs that we have. So all the courses are on pentesteraacademy.com. All the labs are on attackdefense.com. Uh, Now, when you have received the first mail from our side, that after signing up, right, today morning, and for some people it will be evening. So you guys have received a mail from our side that the subject of the mail is instructions for the Wi-Fi bootcamp, right? So in that mail, we have given a link to the Discord channel, Discord server that we are going to use for this bootcamp. If you have not joined that yet, please do, because we are going to use that specific server for all the announcements. After the session, we are going to share our slides there, all the demo videos, the recording of the session, which is made available within 12 hours of the session. So everything is posted on the Discord. Our communication will be done through the Discord server, right? So it's important that you have joined that server. If you have not, please check the mail and please do join it. Now, when you go on Discord server, you will actually find that we have 4 channels there. First one is a general channel. As the name suggests, you can post any questions, any doubts. If you want to, discuss something among all the other attendees of the cohort, you can do that. Then we have announcements channel. In announcement channels, it's obviously reserved to make announcements from our side. So link for each upcoming session is posted in this specific channel. Slides, recordings, everything is posted here. And if we want to convey something to you, that's the channel that we use. The third one is the live instructor interaction channel. And as the name suggests, it will be used during the class to ask questions. So during the class, anytime if you have any doubts, this is the channel that I monitor. So you can put your question here and then we can go over it. We can take your doubt and we can discuss it. And the fourth channel, as you can see, is named resources. So this channel is supposed to contain all the resource links, about different things that we will discuss, about all the relevant resources that I think you will need or will be helpful for you to have. So all of those I am going to post in resources, and you can also do the same. Uh, so okay, okay, yeah. So Mike, yeah, it seems like Mike, you have used our services before, so that's why you know that there is a lab support channel also. But we decided to drop that channel. You can just post it in general or in live instructor interaction, just to keep the number of channels lower. So you can post it there, and I'll then help you out. So guys, just so that I know that you guys can clearly hear me, please drop a hi or hello or something in the live instructor interaction channel, just to make sure that I'm pretty, I'm audible and you guys can clearly hear me. Okay, okay, great, great, thank you. So guys, I'll actually say please use the or prefer the Discord server to message me, because the Zoom messages, right? So sometimes we actually miss them, right? And if even if we have to see them, it actually causes a little bit of distraction. For the Discord server and for this specific channel, I have a separate monitor. So whatever you are posting, I can actually uh, quickly see, whatever your question is, whatever your doubt is, or your comment is. So this is how we are going to communicate for next 4 weeks. You can ask questions anytime you like. There will be time zone gap because some of you guys are from US, some of you are from Singapore, right? Some of you are from Europe. So expect a little time delay in some cases, but I'll try to answer your questions. I'll try to revert back to your comments as soon as I can. Uh, Next thing that I want to talk about is the lab access and Pentester Academy access. So in the instructions mail, you also have a complimentary access token. It's a one-time token which you can use to activate your account on Pentester Academy. And after that, you will be able to access all the courses, all the labs that we have. So what you have to do in that case is you have to go to Pentester Academy. You have this button here. It says member access. Just click on it. After that, it will take you to a Google login page. You can use any valid Google account that you have. You can choose to use your personal account. You can choose to use your work account, or you can even create a new account if you like to, and you can use that. When you sign up using Google, the only two things that we get from it is your name and your email address. That's all, nothing else. So once you have logged in using Google, you will actually see a page like this, right? Provided that you have never been a subscriber of Pentester Academy in the past using the same email address. So you will see something like this. There will be two tabs. First one is start your free trial. The other one is activate your premium subscription. So you have to click on the second tab, and then you have to copy your activation code. You have to paste it here. And as soon as you press the activate button, your subscription will be activated. And now you can access all the courses that we have on Pentester Academy. And you can play all the labs that we have on attackdefense.com. Uh, if you if you have used Pentester Academy before using the same email address, just drop me a DM on Slack, sorry, on Discord, and I'll get my support team to enable your account. Because if you have used our service using the same email address, you won't actually see this section here. Instead, you will actually see that, okay, your subscription is due for renewal. So you won't get the option to enter the activation token, right? So in that case, just let me know. I'll handle it for you and I'll get your account activated. So with that, if you have any questions, anything that you want to ask, till now, whatever we have discussed, just drop me a message in the live instructor interaction channel, and we can answer it. The mail also contains a link to a tutorial video that actually walk you through this activation process, right? So you can also use that one. How long the account will remain active, right? So uh, so when you buy a boot camp is 4 week long, right? So duration of the boot camp is four week. It starts from today, and after 4 weeks, we will do our session 4. So once the boot camp is concluded, for next 7 day, right? So for one more week, you will have the lab access as well as the Discord server access. After that, we will actually revoke the access from the labs, and we will also revoke the access to post your questions or post anything in the Discord channels. So we will not delete the server. So everything that is pasted, that everything that is there, it will remain there, but you won't be able to post anything after 5 weeks from today. So I hope that answers it. Uh, so bootcamp, as you already know, I'm sure that most of you have already gone through the syllabus. It is divided into 4 modules. Each module will be covered in a session, right? And for today, we are going to talk about the module 1. The first module talks about the basics, because we assume that most of you guys, if not all, uh, you have never taken any class on Wi-Fi security, right? And some of you are not even familiar with the basics of Wi-Fi, right? We all have used Wi-Fi, that's for sure. We all have Wi-Fi routers in our home. We have configured the device, but as far as the protocol is concerned, we don't have that clarity. That is our assumption. So that's why we cover everything from the basics. We will talk about the standards, the amendments, the protocol basics, how to perform Wi-Fi traffic analysis, how to perform the traffic capture for Wi-Fi, right? How to perform recon, how to look for the devices that are in the vicinity. So that is all that we are going to cover today. And then in module 2, we will move to the personal network security. In module 3, we will focus on the enterprise grade attacks, right? How to attack enterprise networks. And the module 4 will have some advanced attacks, WPA3, and also we will cover the latest, the frag attacks, which were discovered, a few weeks back. So we will go through them and we will see what exactly they are. They are okay. Yeah. So yeah, Vinayak, the Pentester Academy activation, right? So the access to Pentester Academy and the attack defense will be for 5 weeks. So 4 week is your bootcamp duration, and then 5 week is the period for which you get the complimentary access to attack defense and Pentester Academy and access to this specific Discord server. 5 weeks from today. You're welcome. So guys, with that, let's start with the session. Uh, at any given time, if you have any question related to what we are discussing, right, please feel free to put it in Discord channel, right? Please use the live instructor interaction channel, and we will take the doubts as they come. You don't have to wait, till the end of the session. So first, let's start with Wi-Fi standards and amendments. When we talk about Wi-Fi, the first thing that we have to know, obviously, is the standard, right? What Wi-Fi is, what does this number mean? So whenever we are talking about Wi-Fi, I'm very sure that you guys have heard about this term, IEEE 802.11. So this is the term that is used to refer the Wi-Fi. This is the standard, right? 802.11 is the standard that refers to the Wi-Fi, or WLAN, to be more specific about it. So IEEE stands for Institute of Electrical and Electronics Engineers. That's the main organization that actually creates these standards for most of your network related norms. Yes. The slides will be shared with you just after the session. So you don't have to, take notes of everything. You just focus on the class, right? You can ask questions whenever you like to. So today's session is a little bit heavy from theoretical side, because it is very important to make the base right. Once you know the protocol properly, you can then perform analysis, you can perform the sniffing and capturing of traffic, pretty easy. And that is where most people actually make mistake. Most people think that Wi-Fi security is only about attacking networks, right? And most people actually think that, okay, it's only about web cracking and WPA2 PSK dictionary attack, all of that, right? But it is actually more than that. And to yeah, so class is planned for 2.5 hours. But sometimes if the questions are more, right, and if it takes more time to explain it, it might stretch 15-20 minutes more than that. But you don't have to worry if you have any prior engagement, right? If you have something planned for that, you can actually leave the class, because everything is being recorded, right? And it will be available to you for download after 12 hours of the session, right? So don't worry, you will not miss anything. So coming back to the topic, uh, IEEE is the organization, and in that you have various committees that work on different technologies and different standards. So 802 is the committee that actually deals with the network related norms, and .11 is the working group that is focused on the wireless LAN, right? Uh, so standard is 802.11. Apart from that, everything that you read, right, these additional letters, right, 11A or 11A, if you like to say that, B, G, N, A, C, A, D, right? All of these are amendments. These are not standards. A lot of people make this confusion. Uh, so main standard is, your standard is 802.11, and then all of others are amendments. Second organization that is very important when it comes to Wi-Fi is the Wi-Fi Alliance. It is a non-for-profit organization that actually promotes Wi-Fi, and they actually own this trademark. So this Wi-Fi logo that you are seeing on the right-hand side, it is owned by Wi-Fi Alliance. If you want to use it on your product, right? So any vendor, if they want to use this specific logo on their products, and you will see it almost on all of the Wi-Fi devices that are available out there, right? All the TP links and D links and all the other vendors. So what they have to do in that case is they actually apply for the certification uh, from Wi-Fi Alliance. They have to actually submit their devices there, and then Wi-Fi Alliance will test it. They will make sure that it adheres to Wi-Fi standard, right? And if it does, after that, the certification is granted. And after that only, someone can use this specific logo because it is owned by them. Uh, so they have different certifications, right? One is the basic Wi-Fi certification. Apart from that, there are a lot of other technologies which are there in the devices, and you have seen most of these advertised on the boxes of these devices. For example, Wi-Fi Direct, WPS, Miracast, Wi-Fi Location, right? So all of these are some of these are actually marketing terms, more industry friendly marketing terms, and some of these are your amendments, right? Like 802.11 AC, right? All of those. When we talk about Wi-Fi, most people actually think that Wi-Fi only uses two frequency bands. The most popular one obviously is 2.4 gigahertz. That is amendment B/G, or this is again, these are two amendments. 11B is separate and 11G is another one, right? But we are writing it like this because both of these, they operate in the same band. They operate in 2.4 gigahertz. Another popular band is the 5 gigahertz band, and the amendment for this is 802.11A, right? So these are the most popular ones, but there are other frequency bands also which are supported by Wi-Fi now, right? And some of them have been around for quite some time, but they are not very popular. And why? Uh, because again, it totally depends. So for example, your 11AH, right? So it's called sub gigahertz Wi-Fi. It is again relatively new, uh, and as you can see, it will work on 900 megahertz. And when we say, so it's a you can use it as a guiding principle here, or as a basic thing here, that when the frequency is lower, your bandwidth, right, or your throughput will be lower, but your range will be more. So your reach of that signal will be more, but the capacity of carrying the data will be lower. And don't worry, we will actually go into all of this, but just to give you a very high level idea. So this sub gigahertz Wi-Fi is now becoming popular because people want to use this for your IoT devices. And as we know, most of our IoT devices, they don't actually need a lot of bandwidth, but what they need is range, right? Because if you have deployed a lot of IoT sensors, around in your house, and if you want them to use Wi-Fi as backbone, your 2.4 gigahertz or 5 gigahertz, right, it might not reach them, right? The network might not reach them. So in that case, sub gigahertz Wi-Fi is there, which is now becoming popular. Similarly, there are two other bands which are licensed also, right? So, and it actually tells us why they are not very popular. So all of other bands, right, apart from these two bands, these two amendments, 11Y and 11P, are unlicensed, which means if you want to transmit, if you want to operate Wi-Fi uh, on other five bands, you don't really need any permission from the government or any regulatory authority, right? Whereas in the licensed band, you cannot transmit without a license, right? If you do that in some areas, it is actually a felony. So you should not do that, and that's the reason why they are not, popular. Then comes 802.11ax, right, which is going to use 6 gigahertz, and similarly 11AD is also now, gaining more recognition. So it will use 60 gigahertz, and the basic rule here is, as frequency is increasing, the range of the Wi-Fi signal, right, that is being emitted by the device will actually shrink, right? It will decrease. However, the data carrying capacity will actually increase, right? So that is the basic thing. Now, if we take a look at these Wi-Fi amendments and the names that are being used to refer to these, this is this is this is a chronologic table. If you take a look at it, so you can observe that the first standard, right, the original standard, that was your 802.11, right, it was introduced in 1997, and main thing is this column, right? So you can observe that the max data rate in this case is 2 Mbps, and it is only using 2.4 gigahertz. Then after 2 years, 11B amendment was there. It was done, and in this they are using the same frequency band, but they have increased the data rate to 11 Mbps. Then comes the 11A, which will support 5 gigahertz, and you can see that the max data rate is now drastically brought to 54 Mbps. Then comes 11G. It has speed like your 11A, but it is for 2.4 gigahertz. And then come 11N. 11N will give you a speed up to 300 Mbps. It will work on both 2.4 gigahertz and 5 gigahertz. And this is what is referred to Wi-Fi 4. So these are the terms that now people are using when they refer to these, right? But it is to simplify it. But if you have been in the space, they are actually confusing a little bit. Uh, Similarly, for past few years, 11AC is the one that is getting acceptance and getting adoption. It works on 5 gigahertz, and in this, the theoretical speed, the max data rate that you can achieve, right? Not the speed, actually, the data rate. Uh, that is 1 Gbps. And again, it is theoretical. You will not reach this speed, or sorry, again, data rate in real world. But this is what it is as per the calculation, and we will also see how these max data rates are calculated, right, and how your vendors, they actually calculate the throughputs for their device. So this is referred to as Wi-Fi 5, and the latest one, uh, that is AX, it is called Wi-Fi 6. Now, some people, during the class, you will actually see that we will be focusing more on 11AC, 11N, right? So some people ask us question that, okay, why you are not going behind 11AX then, right? Why you are not covering 11AX? So important thing to note here is these amendments, right? These specific amendments, they don't have anything related to security, right? So they are about the band that you are operating on, right? The technology that they are using, and the way data is being transmitted, right? So all of that will be taken care of by the device that you are using. So if you have a basic understanding of how security works on 11AC or 11N, you will be able to do the same thing on 11AX, right? So it's not bound with the security part. Security part is separate. It's a separate amendment, right? This is about how you transmit the data. So from security point of view, if it was a WLAN deployment class, right? If it was a networking class focused on Wi-Fi, then yes, it makes sense to cover 11AX because that is the latest and greatest one. But from security point of view, it doesn't really matter. If you know how to do things on 11AC, you can just get a 802.11ax compatible device, right? And then you can do the same on that one also with a little bit of tweaks. And that we will, discuss what all you have to take care of when you are discussing this. So we have already discussed that there are a lot of bands, but we are going to focus on two main bands here. And these are the one which are very popular, 2.4 gigahertz and 5 gigahertz. So 2.4 gigahertz band, as we have already seen, there are two amendments that actually talk about these, is 11B and 11G. As you can observe here, this band, it starts from 2.4 gigahertz and it goes till 2.495 gigahertz, right? If you are considering channel 14. So what they have done, this is your band, this is your total space here. You have divided this into multiple channels, right? And when we say channels, this space here, right, from here to here, right, this is called one channel. This is the center frequency here in the middle. Center frequency will be there. And then this is where you are going to transmit the data. It is your channel one, right? Similarly, you have 13 channels that are consequent, and then there is a 14th channel. Now, these channels, the availability of these channels, and if you can use this channel or not, it totally depends on your regulatory authority, right? So different regulation uh, authorities, they have their own standards about it. So some of them, they will allow you to use channel 14, uh, some of them they won't. So it totally depends on in which part of world you actually live in. So depending on that, your device that you are using at your home, it might be able to use 13 channel or 14. So for example, if you're in US or Europe, uh, mostly your devices, they will not actually support channel 14. And it is actually implemented and enforced by the registry domains, and we will actually talk about that too, and we will also talk how you can actually change them. If you're in Japan, you can actually use the channel 14th, right? Now, important thing to notice here is in 2.4 gigahertz, your channels, they actually overlap, right? And you can see that the channel 1 is overlapping with channel 2, 3, 4, 5, right? Similarly, all of these channels are overlapping because you have tried to fit a lot of channels in a limited space, right? And due to this, the problem of interference is there. So when you are using 2.4 gigahertz, there will be a lot of interference if a lot of devices are operating. And for this overlapping, right? If you check channel 1, 6, and 11, you will actually see there is no overlapping, right? And that's the reason that when you actually search on Google, how should I configure my Wi-Fi, or which channel should I choose, they actually the people who are on the forum or on the blog, they actually suggest that you should go for 1, 6, and 11 if you are deploying multiple devices in that specific area, right? Because there won't be interference then, and if there is no interference, the throughput of the area, right, the throughput of that region will actually go up. So when we say throughput, we are actually considering all the data that all the devices in that specific area, right? And in wireless, we actually define these zones in terms of cells. So you can say a cell, if it has 5 devices, right? So in total, how much data they all are able to transmit, that will be the throughput of that specific cell, right? So we are actually taking a look at the, the whole efficiency of all the devices that are in that cell, right? So that actually goes up when you use non-overlapping channels. But if you have a lot of devices, there are other problems also. And due to this, your 2.4 gigahertz will not be able to give you very high speeds, right? That is one reason. That is one reason. And when I say speed, it is not actually the speed. It is throughput. It is data rate, right? Speed is something that people use a lot, but it is not the right thing to say here. All of these are electromagnetic waves. They are using the same speed to travel through the waves. So uh, the right word to use here is the data rate or the throughput. So here you can observe that all of these channels, they are of 22 megahertz. Again, in later slides, you will actually see that instead of 22 megahertz, we have written 20 megahertz. Don't get confused. I'll explain it why it is like that. So this is your 2.4 gigahertz, right? You have 14 channel in total. 1, 6, and 11 are non-overlapping. Each of the channel is of 22 megahertz. For now, let's take it as 22. Uh, and that's about it, right? So if you want to perform sniffing or transmission or anything, you have to select a channel, and then you can perform it on that specific channel, right? And you have to remember this thing. This is one of the main differentiator between LAN sniffing and WLAN sniffing. WLAN is your wireless LAN, right? Wi-Fi. That you can only be on one channel at one given time, right? You cannot listen to all of these channels at one given time. You can only choose one channel and you can operate on that. So this is the 5 gigahertz band now. It's 11A, the amendment, right? So what you can notice in this case is you have non-overlapping channels, right? That's the first observation. Second observation that we have is you have a lot of bandwidth available here, right? You can see the band is quite wide. All of these channels, a lot of channels are there. If you start counting from here, you will actually see that we have way more channel than we had for 2.4 gigahertz. They are non-overlapping. So if you are using two consecutive channels, for example, if one access point is using 36 channel and the other one is using channel 40, in that case also there won't be any interference, right? Which is not true in case of 2.4 gigahertz. And this is one of the reasons why your performance, the performance of your device, right, will be better on 5 gigahertz. Again, it is one of the reasons. There are multiple reasons. uh, Second thing that you can notice here is, in addition to, so all of these channels are of 20 megahertz width, right? So you can see that when you actually combine these two channels, it actually becomes a single channel of 40 megahertz, right? And in similar manner, if you combine four of these, you can actually create a 80 megahertz channel. And on similar concept, if you combine eight of these, you will actually get a 160 megahertz channel. Now, this channel width, right? It also improves the data speed, or sorry, data rate that is possible, right? So if you are using a 40 megahertz channel to transmit the data, you will be able to transmit way more than what you are able to transmit at 20 megahertz, right? It won't be exactly double, right? But it will be more. So similarly, if you are using a 80 megahertz channel, obviously you are going to transmit more data. And this is the main reason, right, why you have better speeds at 5 gigahertz, because you have something called channel bonding, right? So this is channel bonding. When you can combine smaller channels to form a bigger channel, it's called channel bonding, right? So you can create channels of 40 megahertz, 80 megahertz, and 160 megahertz when you are dealing with 11A. right? And not actually just A. This part, right, the lower two part, it actually comes in 11 AC, but we'll talk about it. Beamforming is different. We are going to talk about beamforming also, right? So there are multiple ways of improve the the data rate, right, between the access point and the device. We will talk about that too. So 11A actually deals with your 5 gigahertz. 11B and G deals with 2.4 gigahertz. The main difference between B and G is first thing is due to this max data rate, and this max data rate is different because of the modulation schemes. Now, modulation scheme is the way how you actually modulation and modulation schemes are the way or the techniques by which you actually transmit the wave, right? So just like you have your FM, AM, right? All of that we have learned in basic physics. Uh, in similar manner, when you are transmitting these, they also use different methods of modulation, right? Uh, so due to that, this difference is there. Your 11B, it uses DSSS, whereas your 11G, it uses FQDM, right? But again, you don't have to actually worry about that because from security angle, uh, once you have the right hardware, all of this will actually be taken care of, right? But this difference is the main why you will actually see 22 megahertz in some cases written for the channel width and 20 megahertz in others. So when we are dealing with 11B, the channel width is 20 megahertz. When we are dealing with 11G, the channel width is 20 megahertz, right? That is how it is. That's why the difference is there. So channel bonding is to take two channels and combine them to form a bigger channel, right? In terms of your 5 gigahertz, it's very simple, right? You can take two consecutive channels because they are non-overlapping. Uh, you combine them, you get 40 megahertz, right? It's not that simple in 2.4 gigahertz. So in 2.4 gigahertz, because your channels, they are overlapping, right? So channel bonding is a little bit more complicated. So if on and there are limited 40 megahertz channel that you can form on this band because you have less space. So now here we have combined channel 5 and channel 9. Channel 5 is here, right? It starts from here, it goes till here. And channel 9, it starts from here and it goes till here. But if you check the frequency here and the frequency here, you will actually see that it is a 40 megahertz gap, right? So if we have to perform channel bonding on 2.4 gigahertz to create a 40 megahertz channel, uh, by taking channel 5 as the first channel, right? We will take channel 5 and channel 9, right? So a little bit more complicated than what it is when we talk about the 5 gigahertz band. There is this app. It's called Wi-Fi Analyzer. It's free app. It is available on Google Play. It's been around for quite some years now. So you guys can actually, if you're using Android, I'm not sure if it is available for iOS. You can actually download it. You can install it. I think they show some ads, but I think that's okay for the value that they provide. So this app, it actually shows all of this information on your phone for you, right? So you can just turn on your Wi-Fi, you can open the app, and this app will actually quickly show you if the network that you're using is using channel bonding. It will also show you all the networks that are around. It will also show you the signal and everything, right? So a easier way to take a look at Wi-Fi networks that are around. Again, we will go into all the details, how you can use the proper capturing tool, the proper analysis tool like Wireshark to know all of this. But this one is an easier way to look at. So when you take a look at a 2.4 gigahertz uh, channel, which is a 2.4 gigahertz network, which is using channel bonding, you will actually see something like this, right? So here it has combined channel 7 and channel 11 to create a 40 megahertz channel. Whereas this one you can see is only using one channel, and it is only of 22 megahertz it is saying here, right? So you can say 40 megahertz, 22 megahertz. So this is what actually cause a lot of confusion to most people. So sometimes you will actually see 22 megahertz written here. In some cases you will see 20 megahertz, and it is only in 2.4 gigahertz. In 5 gigahertz you will directly see 20 megahertz channels, right? So I have to check. I think this is available for iOS, but I'm not sure. So I have to check. If you guys can check and let me know, I can then find a similar application for iOS then. Right? Again, just to take a quick look. Uh, so here's the explanation also. I have provided some links which will actually tell you why in some cases you will see 20 megahertz channel, and in others, you will see the 20 megahertz channel. But the main thing is because the modulation schemes that are used in these two amendments are different, right? DSSS and OFDM. Uh, this difference is there. Now, as I already mentioned, you don't really need to know about DSSS and OFDM, but if you are interested, just search on YouTube, and you will find a lot of these, videos, explainer videos that talk about DSSS and OFDM way of transmission, and you can get an idea of it, just the way how your web waves are, are transmitted. So for channel bonding, we have 11N amendment. 11N applies on both the bands, right? It applies to 2.4 gigahertz, it applies to 5 gigahertz. So when you see a Wi-Fi device, right, that says it is 11N compatible, it means that it has channel bonding support, right? That's all that it means. It will not make sure that it also works on 5 gigahertz or not. For that, you have to see that if it supports 11A, right? That is the amendment. So 11N allows you to perform channel bonding on 2.4 and 5 gigahertz channel. It allows you to combine two channels to create a 40 megahertz channel, right? And then there are all the other things that it allows you, but we have not covered them yet. So, just ignore them for now. Similarly, for 5 gigahertz, the latest amendment, right, 802.11 AC, latest amendment in use. Apart from that, there are other amendments also. So in 11 AC, what they did, they said, okay, for 2.4 gigahertz, we can only create channels up to 40 megahertz because we don't really have that kind of bandwidth available there. But for 50 for 5 gigahertz, we actually have a lot of bands, and all of these bands are non-overlapping. So why to stop at 40 megahertz, right? Why not to go to 80 and 160 megahertz? And that's what 11AC actually does. So 11AC allows you to do this kind of bonding, right? So first one is the basic amendment, right? So this 20 megahertz is your 11A amendment. The 40 megahertz is supported by 11N, and then 11AC is responsible for the 80 megahertz and 160 megahertz bands, right? For your 2.4 gigahertz band, only three amendments are there. Uh, that is 11B, 11G, and 11N. And 11N and 11AC are for channel bonding. So main difference between your 2.4 gigahertz and 5 gigahertz band is in terms of performance and the reach, right? Now you can clearly observe from this graph here that the interference is very high in 2.4 gigahertz. Now we already know why it is like that. The first reason obviously is because your bands are overlapping with each other. So if you are operating devices uh, in overlapping bands, there are going to be interference, and it will actually bring down the total throughput of that specific cell. In 5 gigahertz, the interference is very low. Now you can say that why it is there, right? There are non-overlapping channels. So why there is interference? That's the thing about wireless, right? So interference is going to be there, right? There is going to be some kind of interference always. So it's not due to the overlapping channel, right? It can be due to other factors also. Then comes the range. Your 2.4 gigahertz will have better range than your 5 gigahertz uh, Wi-Fi. In terms of bandwidth, obviously the 5 gigahertz will actually support way more bandwidth than your 2.4 gigahertz. And this is first reason obviously is the non-overlapping channels, and then comes your channel bonding and all of other things, right? So again, a simple chart showing the signal strength in two different settings. The red one is considering that it's a 65 feet distance. There are 3 walls and 1 floor, and after 65 feet, it is actually checking the signal. On the second one, it's a 10 feet distance from the source, and when we say source, it's the access point, right? And it is line of sight. There is no wall, there is nothing, there is no obstruction, right? So if we check the signal in these two settings, and if we do this comparative study for 5 gigahertz and 2.4 gigahertz, we can clearly see that 2.4 gigahertz is actually going way farther than your 5 gigahertz. And why does that happens? Because that is the basic physics, right? Your attenuation is the loss of the signal, right? So when we are talking about a wave like this, the farther wave goes from its source, its amplitude, in this case, its amplitude will actually decrease, which means it is losing its signal strength, right? Which we actually measure in dBms. So when we plot 5 gigahertz wave and 2.4 gigahertz, we can clearly see that 5 gigahertz, it has more frequency, right? Uh, in terms of 2.4 gigahertz, right? It is even evident from the term itself, right? So uh, your higher the frequency, lesser the reach is, right? Because your attenuation, it is directly proportional to the frequency. So due to this, your lower frequency waves will actually go farther. And that's the reason why sub gigahertz Wi-Fi will even go farther than 2.4 gigahertz Wi-Fi. And that's the reason why it is being considered for IoT based devices, right? To provide connectivity for IoT devices. So as currently, in our home networks, in our home Wi-Fi, we have 2.4 gigahertz and 5 gigahertz, right? And the suggested deployment is that you should keep this device near to your IPTV or your smart TV or your gaming console, which will need way more higher throughput, right? And then you can have your phones and laptops you can even use from a little far. So here, in that setup, what you are actually trying to do is you are trying to make sure that the 5 gigahertz range, which will be lower than 2.4 gigahertz range, will actually support the high throughput devices. And then 2.4 gigahertz will provide a larger cover, which will cover all the rooms that you have, in your house. And, you can use phone and your laptop using that. In similar manner, what we might see in upcoming years is there will be 3 Wi-Fis. The third layer of a 900 megahertz Wi-Fi or sub gigahertz Wi-Fi will be there, which will be there to connect our IoT sensors to, right? So this is something that we can see in some time in near future. So if we have to take a look at Wi-Fi generations, we can see that the main thing here, right? Main thing that we are trying to achieve is we are trying to increase the link rate or the data rate, right? Again, all of these are theoretical values. The higher ones are theoreticals, right? So not really achievable. But thing is, if you have a higher maximum theoretical value, you will be able to achieve the real throughput value in proportion to that, right? Not exactly that, but obviously in proportion to that. So now let's talk about how the signal is transmitted, what are different factors that are considered, right? And how, so all of the factors that we are going to take a look at, they are actually important when it comes to capturing the Wi-Fi traffic properly, right? So we are only focusing on that. It's not from performance angle, right? Because we are not, the course is not how to make your Wi-Fi perform better, but how to capture and analyze the Wi-Fi traffic better, right? So that you can execute attacks, you can analyze what is happening, right? All of that is our objective. Uh, so this is a very simple scenario. You have one transmitter and one receiver, right? The transmitter also has one antenna. The receiver also has one antenna, right? So you can think of a Wi-Fi access point, which is like 15 years old, and similarly a Wi-Fi capable device, which is like 5-10 years old, right? So they used to have this kind of setup. Only one antenna on the both sides, and then this is the transmitter, this is the receiver, denoted by TX and RX. So things are simple here. You are transmitting from this device, the signal is reaching here, and it is then receiving the signal. It is then again converting this analog signal into digital signal, and then the digital signal is converted into packets, and your communication takes place, right? Uh, this is the basic thing, right? It's called CISO, that is single input, single output, right? The simplest possible thing. Then comes antenna diversity, right? So in antenna diversity, you have multiple antennas with you, right? On both transmitter and receiver end. And why this is needed? Because what happens, and this problem is very specific to uh, your wireless communication mediums, right? It's called multipath. So what happens in multipath is, when we are transmitting from the transmitter, right? In theory, we can always draw an arrow like this, right? We can assume that, okay, the communication is happening in line of sight, right? Our wave is going from this and it is directly going to the RX, but that does not happen in real world, right? In real world, what will happen when you are emitting a wave? The wave is actually going to all the sides, right? If you are using an omnidirectional antenna, it will actually go all the sides. Even if you are using a directional antenna, and don't worry if you don't know about this, all of this we are going to cover. So even if you are transmitting in this direction, the wave does not travel like an arrow, right? It's not a vector arrow that will travel like this. The wave will go to this side also, right? It will go to this side also. uh, just a minute. Yeah, I'll actually, okay. Mm, just finding a pen, just a minute. Yeah, so yeah, wave will also go to this direction, wave will also go to this direction, and also go to this direction. Now the problem is, suppose you are inside a room, right? You will have a floor ceiling here, you will have a floor here, right? Ceiling, floor. Then you might have a table or something, right, kept here. So what happens is, this same wave, right, because it is going into so many directions, it is going to reach this destination using different paths. So a portion of wave will reach like this, other portion will reach like this, it will go to the ceiling, it will reflect from the ceiling, and it will come here. Similarly, a portion will go like this, and it will reflect from the floor, and it will reach here, right? So what happens is, because all of these signals, right, they are reaching after a time delay, because this path, right, the speed is same, right? The speed of traveling of this wave is same, but the paths are different. This path is longer than this path, right? So this is going to take more time in comparison to this one, right? If it takes time t, this one is going to take time t dash, right? Where t dash is more than t. So due to this, when these signals will reach the receiver, there will be a phase difference. They are not going to reach in the same way, right? So this is the first wave that reached, right? This is the one that reached directly. This one, it came, after bouncing on the ceiling, right? So you can see there is this delta, right? This difference, right? So this difference actually weaks the signal. So when this receiver will get the resultant wave out, this wave will not have this kind of signal. It will be lower than this, right? That's the problem. That's the issue with your multipath. So to tackle that, what we actually do, just a minute. Okay, I have to close this. Okay, yeah. So to take care of multipath, we have antenna diversity, right? It is very important to understand because a lot of people actually confuse it. A lot of people don't know why we have multiple antennas, and then, is it really going to increase the throughput, or if it is going to, what is the main factor, right? That's why it is important to understand, and it will actually help us in selecting the right hardware for for uh, for capturing the traffic. Wi-Fi sniffing is not as simple now as it was 5 or 10 years back, right? It has become more complex because your equipments have become more better, and they have improved their efficiency, their throughput, using different measures. So that is what we are taking a look at. So when you have multiple antennas, again, because wave is going to reach the antennas using different paths, but what will happen, the signal transmitted by this guy, this first antenna, will be picked up by antenna 1 also and antenna 2 also, right? So suppose this is the signal that is received by antenna 1, and then you have this signal that is picked by antenna 2. So now, by using the DSP, or digital signal processing, on this side, because now your chips, they have become more intelligent, so they can do better processing, right? They have become more powerful. So by using different signals collected by different antennas, the resultant signal can be it can be better. You can actually process the signals that you have received, and you can process it to get a better resultant signal. That is what this line is signifying, right? So that is the benefit of antenna diversity. So here we are transmitting the same thing, right? We are transmitting the same thing from both the antennas here, uh, and we are getting a better resultant wave on this end, right? So this is the benefit of having multiple antennas, right? This is the first benefit, I'll say. We are going to use these in other ways also, but that's the first way. If you have multiple antennas, your performance is going to improve just due to the compensation of multipath effect, right? We are trying to cancel the multipath effect by using multiple antennas. So this is the first concept. Second concept is of spatial streams. Please let me know if something is not clear. I will explain it again. I'll make sure that you get it, right? What we are trying to discuss here. The second thing that you have to understand is the spatial streams. In this example, we were considering that, okay, both of these antennas, it is transmitting the same signal, right? And we know how these antennas work, right? Antennas are actually a kind of sensors, right? You can even say, uh, yeah, these are kind of sensors which will take your electricity and they will convert it into the waves, right? You are taking a digital signal and you are converting it into analog signal on the transmitter end. On the receiver end, you are actually taking the analog signal and you are converting it into digital signal, right? But here we have considered that both of these antennas are transmitting the same thing, right? Now let's talk about spatial stream. In spatial streams, what we are doing, instead of transmitting the same data from different antennas, right, from multiple antennas, what we are doing is we are taking this data stream that we want to transmit, right? We are dividing it into multiple parts, right? So suppose if I want to transmit this part, I am dividing it into two parts, right? One is denoted by red, other one is denoted by blue. And suppose I have, I have these transmitters here, right? You can say I have three antennas here. And from these antennas, I'm using this antenna one to transmit this part, right? The part denoted in red. And the other antenna I'm using for this, right? For the lower part that is denoted in blue. So what will happen? These antennas, they are going to transmit this signal. Again, the same signal that is transmitted by this antenna 1 will be picked up by antenna 1, 2, and 3 of the receiver end. The digital signal processing will be applied on it, and then you will get a resultant stream right here. Similarly, at the same time, when you are transmitting from this antenna, you are also transmitting from this antenna, right? And from this antenna, you are transmitting this part of the data stream, right? And it is also being transmitted, it is being picked up by these antennas, and it is processed, and you are getting the data stream here. Now, what has changed? So when we were doing it in this case, uh, we were transmitting the same data, right? So suppose if we want to transmit X amount of data, it is taking us time T. However, here, because I am using two streams, right? When I am transmitting the data here, I am making sure that I have divided it into two, right? So if in previous example, we were using, say, data D was there, and we were taking time T to transmit it, right? In this case, because I have divided the data into two parts, right? And I'm transmitting these at the same time. So what will happen to transmit the same data D? Now, uh, I should take around half of the time that I was using before, right? So what I have done here, I have improved the throughput of the system. When I was transmitting D data in time T, now I am transmitting this data in half of the time, right? So that's good, right? So that is where your spatial streams are coming into play, right? These are the spatial streams. So how many parts you are creating out of this data stream, right? And which are being transmitted at the same time, that is what a spatial stream is. In your 11N amendment, you have support of up to 4 spatial streams. In your 11AC, you have support up to 8 spatial streams, right? And as we have clearly seen in this case, the more streams you have, the more data you will be able to transmit at the same time. Uh, it is denoted by in industry like this, right? So whenever you are going to buy a device, uh, it will be denoted like this. It says 3x3:2, right? In some cases you will find 3 here. In some cases you might even go higher, but you will always see that this number will always less than this number. So the first number here, it denotes the transmitters. It says 3, which means we have 3 transmitters on the device. Then the second number, it denotes receivers. It again says 3, which means we also have 3 receivers, right? And then it says 2 here, which means that the spatial streams that this specific device supports is 2. So just because your device that you are using, and again, I'm referring to your Wi-Fi access points here because they are easier, to take a look at and to understand, right? Because their antennas are external. For your own laptop and your for own mobile, you have to actually take a look at the specs to know how many antennas your device has, because the antennas are internal in that case. But in most of the Wi-Fi access points, you will actually find that the antennas are outside. So you can actually tell that, okay, this will be faster than other one or not by just taking a look at the antennas first. And after that, when you want to go into details, then you check for the spatial streams on the box or on the specification. So more the special stream support is there, the better this device can perform. That's the basic rule. Okay, so we have learned antenna diversity, we have learned spatial streams. Now let's talk about single user MIMO, right? So what is single user MIMO here? Single user MIMO means you have this one device, this access point is there, right? And say it is supporting up to 4 spatial streams, right? And then you have say a device on the other end, right? And that also has say 4 spatial stream support, right? So what you can actually do is when you are transmitting to that device, you can actually use MIMO, right? MIMO means multiple in, multiple out. So this thing here is a MIMO. What was SISO? This is SISO, right? What is MIMO? This is MIMO. You have multiple transmitters, you have multiple receivers, and you have multiple data streams, right? So that is your single user MIMO. Your access point is communicating with one device at a time. That's why it is called as single user MIMO, right? Uh, so again, if you are not clear about it, your Wi-Fi is a shared media, right? So when we are talking about one cell, right? So suppose uh, this is your access point here, right? Suppose this is the range of access point. Again, I'm drawing a circular range here, a spherical range or circular range, just for the simplicity. Otherwise, in real world, this is not how it is. In real world, your range will be more of a oval kind of thing, right? And then again, it totally depends on the kind of antenna that you are using. We are going to discuss about that too. But suppose this is your access point, and then suppose you have a phone here, right? You have a laptop here, you have another phone here, and then you have another laptop here, right? So the way Wi-Fi works is at one given time in this specific cell, only one device can transmit. That is the basic rule, right? It is called listen before you speak, uh, way of transmitting. So whenever any device, whether it is access point or it is client, when they want to transmit, they first make sure that the other devices are not transmitting. When no device is transmitting, that device is going to transmit, and all the other devices will not transmit at that time, right? So suppose first this guy will transmit. Once it is done, after that this guy can transmit, then this guy will transmit, and then this guy will transmit, and then the other guy will transmit, right? So if two of your devices are transmitting at the same time, it is going to cause issues, right? It is going to cause interference. That's why at one given time, at one channel, so suppose it is for channel 6, say, right? So all of these devices are channel 6. On channel 6 only, one device will be transmitting at one time. And again, this is the reason why the performance of your 2.4 gigahertz Wi-Fi actually goes even below when goes even down when you are in a densely in a dense Wi-Fi deployment environment, right? So suppose if you have multiple, like 20 devices in this specific cell on this same channel, again, because they are going to transmit sequentially, right? So obviously it is going to take time for your device to get its slot for transmitting, right? And that actually brings down the whole throughput of that specific cell. That's the reason why Wi-Fi deployments, when they are done in your offices, in your complexes, in your malls, uh, the deployers, they make sure to keep the cells smaller, right? You can always increase the transmission, you can always increase the transmission power, and you can make the cell bigger, but that is actually counterintuitive when it comes to efficiency. So it's not done, right? So this is how your Wi-Fi devices actually transmit. So when we talk about single user MIMO, the way it will work is, suppose this is your access point, it has support for 4 streams, which means it can divide the data that it wants to transmit into 4 parts and transmit all the 4 parts at the same time, right? Now it is important to understand that only one party won't be able to, use its capacity to fullest if the other party does not support it, right? So suppose you have one device, that is your phone. It only has support for 2 spatial streams, right? And then you have your access point here, and it has support for 4 streams. So in that case, when these 2 devices want to communicate with each other, they only will be able to use 2 streams, right? They won't be able to use 4 streams. Why? Because this guy will not understand, right? It is not capable of 4 streams. So you can only use 2 streams. So that's why it is not only dependent on your Wi-Fi access point, but also on your device that you are using, your phone, your laptop, right? Uh, uh, so both of these, the complete pair actually will decide, how much throughput, how much data rate you are going to get. And most of the newer phones, right, your iPhones and most of the Samsung phones that cost, beyond, I'll say, $600-700, they actually have support for 2 spatial streams. Most of the laptops also come with 2 spatial streams now. So when we talk about single user MIMO, what will happen? You have, suppose, 4 devices in this cell, right? These 3 devices are connected to this guy. Now, this guy, this access point, will first connect to this laptop. It will transmit data. Then laptop might send data back to this. Then, so first communication is like this. Second communication is like this. Then it will talk to this guy. Then this guy will talk back. And then this guy will talk to this guy. And then this guy will talk back to this guy, right? So there are 6 interactions, right? Now, that is single user MIMO. You are using MIMO, but you're using it with one user at one time, right? However, when it comes to multi-user MIMO, you are using MIMO with multiple users at the same time, right? Now here, whatever I have explained to you in the diagram that I had just drawn here, uh, that thing we are going to challenge in this concept. So now here, suppose this device, right, your laptop, it has support for 2 streams. Your phone, both the phone devices here, they have support for 1 stream each. And obviously your access point has support for 4 streams, right? So what the access point can do when it wants to transmit to these devices, it can do this in one go because it has support for 4 streams, right? So what it can do, it can dedicate 2 streams for this guy, 1 stream for this guy, and 1 stream for this guy, and it can make the communication at the same time, right? So this, and this is happening in one go. Now, once this is done, after that, this guy can transmit to this guy can transmit to this guy, and this guy can transmit to this guy, right? So instead of doing 6 interactions here, now you have brought down the interactions to 4, right? So you can see the improvement. Now you are taking less time, right? If you took 6t here, and again this t is just to simplify it. Otherwise, this time slot is also variable. It's not constant, right? It is not t always. So here you have brought down this to 4t, right? So in this manner, your multi-user MIMO will improve the performance even more. But now you can ask me that, okay, but how it is possible, right? How it is transmitting to multiple devices at the same time, right? So that is where your beamforming will actually come into play. So what is beamforming? Beamforming is a way by which you can transmit to multiple devices at the same time, and you can also make sure that these devices, they get best of the signal, right? How? So when we talk about omnidirectional antennas, right? Omnidirectional antennas are the one which actually transmit in all the directions. And when we want to, whenever we talk about the omnidirectional antennas, this is how we depict them. But this is not how it actually, works. In most cases, depending on how your, device is placed, it's more of an oval, like this it can be, even in case of oval antennas, right? Sorry, like this, right? And similarly, it can also be like this on longitudinal way, right? Uh, but we use perfect sphere to, for the diagrams. In most cases, you will actually see a diagram like this, but it does not work like that. So in the omnidirectional, when you are transmitting in all of this area, right? But in beamforming, when you are doing this, you don't actually transmit in all the area, but you try to focus the signal uh, onto the device. That is what beamforming is, right? So let's see how it actually works. Suppose this is your device here, right? This is your access point, right? And now you are transmitting this signal, right? The same signal is being transmitted by both of these antennas. Uh, Now, in the physics, right? I'm very sure that you guys have learned about the constructive superimposition and destructive superimposition of the waves. So when your analog waves, right, they travel in the air, if they overlap each other, and if the overlapping is in phase, in that case, what happens is wherever they will overlap in phase, the resultant amplitude will actually increase, and it is called constructive interference, right? And it will actually be good for the wave, right? You will actually get better amplitude. That means better signal. So now, when your device is not smart, when it is not forming the beam, it is transmitting like this, and automatically at some place this beam will be formed, right? This beam is nothing but the places where the constructive interference is, happening in these two waves. So this part here, the signal will be better in this line. So your device is not in the line of this, so it is not getting benefited, right? The signal strength will be like this. However, when you perform beamforming, right, what you do is your device, your access point, right, it is smart here in this case. What it can do, it can transmit in such a manner that the constructive interference will happen in the path that it wanted to be. So when the device is here, it will adjust its signal in such a manner that this constructive interference will happen in this direction. So what will happen? Because the amplitude of this wave will increase in this direction here, this guy here, this device here, it will actually get benefit of it, and the signal will be improved for this guy, right? That is beamforming. And if you have multiple antennas, if you have even more antennas, you can actually do it for multi-parties also, like this, right? So this is your beamforming. Beamforming is of two types. First one is the explicit. In explicit beamforming, both access point and the client, they have support for beamforming. And in this, what happens, the client even helps access point in figuring out its location, right? So that it can perform beamforming in a more efficient way. The other one is the implicit or the universal beamforming. In this one, your client does not have the support, but access point will still try to perform the beamforming, right? Any questions till here, guys? Any questions? And it's totally okay if you don't have questions right now. Sometimes it takes time to digest all of this first time, right? You will also get the slides. You go through the slides. If you have any questions at any given time, just let me know. Okay, guys, great. So now coming to the next step, right? I'm spending a lot of time in this section because I want it to be clear, right? Because this is where most people actually make mistakes. Okay, cool. So now let's talk about how the throughput is calculated. And this part will actually be helpful for us to understand, what kind of device we want when we want to target a specific setup. So when we talk about the 11B amendment, right? we know that the advertised speed is 11 Mbps. And again, speed is written here. I have directly used this specific screenshot from this source that is mentioned here. But again, speed is not the right thing to use here. You should use throughput or data rate. So advertised data rate here is 11 Mbps. And as I was telling you, it is more of a theoretical data rate. The real world throughput that people have observed on this amendment is 4.5. Similarly, when it comes to 11G, it is 14.5, right? For 11G without 11B compatibility, it is 23. For 11G MIMO, it is 45, right? Now you already know what MIMO is. When you deal with 11N, right, it goes up to 74. And similarly, it can also go up to 144 when you are using multiple special streams and channel bonding. So for a 40 megahertz channel on 2.4 gigahertz, which is using 64 QAMs. Now again, the question can come, what is QAM, right? Again, it is not important from security point of view. It's more about how the signal is modulated. So as I was mentioning before, right, you have your FM, you have your AM, amplitude modulation, frequency modulation, right? In that sense only, there is one more technique which is more advanced than these. It's called QAM. It's the quadrature amplitude modulation, right? I have added a link here. If you're interested in knowing what QAM is, you can actually read on it. The more this number is, right, the better throughput you are going to get. And in 11N, you will actually see it's 64 QAM, the highest limit, right? When you deal with 11AC, it will actually be 256 QAM. So this is another factor which actually increases the throughput. So our wireless engineers, right, our Wi-Fi engineers, they are actually using a lot of different aspects, a lot of different optimizations to improve the throughput, right? It's not only possible to increase the channel width, right? Because after 160 megahertz, how big you can go, right? So there are other things to improve them. So one of that thing is this QAM. So for the calculation of throughput, we are considering this case. We are using 64 QAM, a 40 megahertz channel on 2.4 gigahertz band. So in that case, you can actually achieve 150 Mbps of advertised data rate. And that is for one spatial stream. Now, if you take two spatial streams, it will go up to 300 Mbps. If you go for three spatial streams, obviously, we are just multiplying this by the number of streams. And for four, you can go up to 600 Mbps. Again, all of this is advertised, right? We are trying to understand how your vendors, they actually advertise this on their box. So when we are dealing with these vendor machines, right, and most of the times these are your off-the-shelf, routers that you can get from a store, right, a Walmart or something, or you can order them from Amazon or something. So you have names like this, right? So if you have to decode this name, here D-Link obviously is the company. AC means that it supports 11 AC. And if something is supporting 11 AC, it is going to support 11N also. And it is also supporting the 11A, right? Because AC is specific to 5 gigahertz. And if something is supporting 5 gigahertz, it is actually kind of mandatory only that it will also support 2.4 gigahertz, right? So from this much, we can tell that it has dual band support. It will support channel bonding on both, your 2.4 gigahertz and 5 gigahertz. Now, how they are calculating this number, this 1200 Mbps, right? So what they are doing here is they are considering that on 2.4 gigahertz, they can use two spatial streams. And all of this is written in their specification, right? How many spatial streams they support, it is written in the specification. So on 2.4 gigahertz, it is assuming that it can use two spatial streams. And as we already know, if we are using a 40 megahertz channel, right? For one stream, the advertised data rate is 150 Mbps. So by multiplying it in two, we get 300 Mbps. And similarly, on 5 gigahertz band, right? Just like you have 150 Mbps advertised data rate for one spatial stream on your 2.4 gigahertz, when we talk about 5 gigahertz, this is 433. And if you have two spatial streams, it will actually come to approximately this. And then you add this and it will approximately come around to this round number. That is how they come up with these numbers, right? You are not going to get 1200 Mbps in real, right? It is not the data, uh, you know data rate. It is not. It is the combined throughput that the device can give at a given point of time when you are using both of these bands on these conditions. That's what this number actually depicts. TP-Link also uses this. A lot of other vendors also use this thing. So you can observe here, right? Uh, this is for uh, this is for D-Link. Yeah, this is for D-Link. So here you can observe, uh, if you are going for AC 1750, right? This is the name of the device, just like this one is AC 1200. You have AC 750, you have AC 900. So AC 750 here means that this guy, it supports three spatial streams. It can go up to 80 megahertz channel width, right, on 5 gigahertz, and it can support three spatial streams and 40 megahertz channel on 2.4 gigahertz, right? So 150 into 3 is to 450, and here 433 into 3 will approximate come around to 1300 Mbps. When you add these, it will come to 750, right? So this is how you can actually decode these names, and you can, from this calculation also, you can actually tell what the capacity of the device is, right? This is what it can do. So when you go to look for the devices, right, this is how you can actually find, you can tell that, okay, this is the right device or not. So now let's talk about the traffic sniffing setup. Uh, Guys, let's take a 5-minute break. You guys can grab a coffee or something if you like to, or drink some water, and we'll meet here again in 5 minutes. Welcome back, guys. So let's continue with the remaining part. So let's talk about the traffic sniffing, right? So I'm very sure that most of you guys have already performed IP traffic sniffing on your Ethernet interfaces using your Wireshark or Tshark or TCP dump. If you have not heard of Tshark before, it is the CLI cousin of Wireshark. So when you install Wireshark, it is automatically installed. And if you have only GUI, and if you want the power of, so we all have used TCP dump, right? Whenever we have CLI access to our server, whenever we want to capture some packets, we always use TCP dump. But as we know, right, Wireshark has way more and way better filters when it comes to filtering the traffic, right, than the TCP dump. TCP dump has filters, but those filters are not very powerful. So in those cases, you can actually use Tshark. So Tshark actually supports all the filters that are available in Wireshark, and you can also use it for packet dumping, creating the PCAP, and all of that. Now, how your wireless sniffing is different from your Ethernet sniffing, right? Uh, it is a little different. How? Because when you are sniffing on the Ethernet, right, uh, you know for sure that all the frames that are coming to that Ethernet interface, you will be able to see those if you are operating in promiscuous mode, right? So you have your Ethernet interface that is on your machine. Uh, in normal mode, it will not show you all the frames that it is getting, right? I'm talking about the Ethernet frames. It will only show those which are meant for your interface, right? Depending on the MAC address of your interface. However, when you put it in promiscuous mode, you will be able to see all the frames that are hitting on your interface. On similar manner, right? In similar manner, on wireless side, when you are using a wireless interface, you are only going to see those frames, those packets which were meant for your interface. However, if you put it in monitor mode, you will be able to see all the frames that it is able to see in the area, right? In the vicinity. So monitor mode is kind of equivalent of promiscuous mode in the wide side, right? Uh, there are multiple tools that you can use to perform sniffing, right? To put your card in monitor mode. First of all, obviously, you are going to need the card, right? Uh, our laptops, they come with cards, but most of these cards, they are not they don't have support for monitor mode. So they are there for normal operation. They can act as a client, but they don't have support for monitor mode because it was not needed in the normal operation, right? So in most cases, what you have to actually do is you have to go for external USB based card, like the ones that I have shown here in the image. Don't worry about what the names and links for these cards. I will actually paste all of that in the Discord server. So if you want to take a look, or if you want to buy it for your own kit, you can do that. For this course, it is not required that you have a hardware setup, because we are going to do most of these things inside our labs. But if you want to try out these in real world, right, then you will need a card, obviously. This one is a TP-Link based USB card. This one is a Alpha card, again very popular one. This is Sevius. The only difference this one has is that it works on Windows also. So they do provide you a deriver that will work on Windows, so you will be able to perform monitor mode sniffing on your Windows machine. But again, because it supports Windows, it's a little bit more expensive. So links for these I will post in the resources channel, so you can check them out. Again, not really required for the course, but if you want to perform it in real world, if you want to get the hands-on experience, you can go for these. We will also talk about what kind of utilities we can use to perform the sniffing. So what all, okay, will Hack5 Pineapple? Yes, yes, yes. So what they actually do is they take AP like access point like platform, and then they write their own custom firmware on it. So yes, in that case, yes, it actually works as a sniffer card. This is the link for these, right? You will also need a Kali VM. I'm saying Kali, you can use any Ubuntu machine or any Linux-based distribution, but it's better to go with Kali because most of cards they will actually work directly on Kali. That's first thing. Second thing, most of tools comes pre-installed on Kali, right? So it will actually save your time. Now, obviously, we know that we can go on Kali's website, and from there we can download the ISO, and then we can install the Kali on your VMware or your VirtualBox, right? But that actually takes time, right? It will take a lot of time. If you don't want to do that, if you want to save your time, you can directly go to osboxes.org, right? So what these guys do, they actually provide you pre-created VM images, right? So if you go here, you'll actually see that you can directly download the VirtualBox file, the VMware file, right? It will save your time. That's all. So you can directly download it. You can open it with these two tools, any one of these two tools, and you can then attach your Wi-Fi USB card to your machine. You can mount it onto your VM, and you are good to go. After that, you can perform, the monitor mode sniffing. And don't worry, we'll go about all the steps, what all you have to do. But this is the basic setup that you will need on your side to perform the basic level Wi-Fi sniffing. Uh, okay, we have a question, so I can use it like a alpha card. That bit I have to check because I have not seen Hack 5 for a very long period now. So I'm not sure if we can use it exactly like that, but I am very sure that they must have provided, the traffic sniffing capabilities with it. I'm not sure how they actually show this to you, but it should be there. It has monitor mode support that I know for sure, but how you will be able to access that traffic that I'm not sure about. So what I can do, I can actually check their latest demo video and I can answer your question. Yeah. So that part I'm not sure about because I have not checked, it for quite some years now. I'll do that and I'll let you know. So what are the main key differentiators with the wide sniffing? First thing is the concept of channel and band is not there in the wired sniffing, right? It's only in wireless sniffing. So you have multiple bands, even if we ignore all the other bands, 2.4 gigahertz and 5 gigahertz, still you have two bands. And then the bands have multiple channels, right? On your 2.4 gigahertz, you have like 14 channels. On your 5 gigahertz, you have even more. And your wireless card can only be at one channel at a given time, right? You cannot sniff all of it at the same time. So that again creates a hurdle and a difference when it comes to Wi-Fi sniffing or wireless sniffing. You cannot sniff all the channels at the same time, right? You can only be at one channel and at one band, even if when your card supports both bands. Uh, so actually, any card, right? Any card. Yeah. So the card that you are posting, right? Uh, this is Alpha, which is supporting the 802.11 AC. So obviously it supports both the bands, but at one time it can either be on 2.4 gigahertz or 5 gigahertz. It cannot be on both at the same time. Similarly, if you have set it to channel 6, it will be on channel 6. It won't be able to see what is uh, okay. So that is new. Okay. Yeah. Okay. So yeah. So the way you have done it, it is actually jumping on those channels. So the way we perform it, when you have to monitor, double bands, and you have to monitor even a single band and all the channels, what the card actually does, what your software actually does, it will actually command the card to jump on these channels. So it will change the channels quickly. It will stay uh, on channel 1 for a time period t, then it will move to channel 2, then it will move to channel 3, then it will move to channel 4 and 5 and 6 and so on, right? So it is done to take sample traffic from all of the channels, right? you cannot operate on all the channels at the same time. That is for Recon, what you have done. And you can even verify this if you put your card into access point mode, right? It will stay on one channel, and after that, if you try to perform sniffing, it won't work, right? It won't be able to see the traffic that is on other channel. So that is a limitation, and it is a behavioral limitation. You cannot do much about it. And then there are more complications, right? You have multiple bands if you want to cover all. Uh, in some countries, some of the channels are allowed. In others, they are not allowed. Then there are the maximum power levels that are allowed, and all of these are enforced. But you can actually, configure your wireless card to disregard these restrictions. So now this is the easier side, right, that we were talking about. You can take the USB card, you can take a Kali machine, and you can sniff the traffic. However, when it comes to sniff the high throughput networks, right? Suppose if you are going to target the 11 AC, right? And when we say 11 AC, the card that Mike has posted on this live instructor interaction channel on Discord, right? It's a Alpha 802.11 AC capable card, right? It is a AC 1200, and from AC 1200, I can actually predict that it is supporting two streams on your 2.4 gigahertz and your 5 gigahertz, right? Two streams each. However, when we are talking about high throughput environments, densely populated, Wi-Fi environments like a corporate network, it is possible to find devices and links that are using up to 4 special streams, right? So in that case, if you are using a USB based adapter, there are more challenges, right? For example, the support of maximum bands, right? So streams, sorry. If your card is only supporting 2 streams, how you are going to capture all the traffic in a 4 stream environment, right? So suppose there are 2 devices which are using 4 streams to communicate. Your 2 stream device won't be able to capture the data packets in that case, right? Then another limitation is because a lot of data is being transmitted, right? And then your card is connected to the USB interface, right? So even if it is able to capture all the Wi-Fi traffic, when it has to send that traffic to your machine over the USB interface, the USB interface can also become a bottleneck in some cases, right? So if you are targeting a network like that, and again, it is not something that all of you will need, right? But uh, but it can be there, right? You might have to face this issue also. That's why we are actually covering it. So what we can do in that case is we can move beyond USB based sniffers also, right? And how we can do that? We can actually modify the access points. So what we can do is we can take some 11 AC high throughput device, and then we can modify it. We can modify its firmware, because your access points, they are high performance devices, right? They have more antennas, they have better chips, they support more streams, right? For example, your 11 AC wave 2 access points, they actually support up to 8 streams, right? So if you can create a sniffer out of it, you can actually uh, capture traffic, all the traffic, even for a 4 stream connection, right? Then these access points, they also have gigabit Ethernet connections, right? The LAN cable slot, which is gigabit in capacity, right? So the throughput is not a problem there, right? It can actually transmit GBs of traffic to you, right? Or not, if not GBs, MBs of traffic. Similarly, the remote capture is also possible using these access points, because you can deploy them, in different locations, and you just have to plug the Ethernet connection, like Ethernet cable to it, and then it can send the packets back to you over that Ethernet connection, right? The only downside of this is pricing. The better hardware you go for, it will be expensive. it will be a little complicated, because if you have to modify it and if you make some mistake, the device is gone. So the complexity is there, but benefits are also there. uh, if we have to strike a middle ground, right, if we have to find a device which is not very cheap, but it can give us a feeler of what it looks like, to have a modified access point as a sniffer, we can take a cost effective, or I'll say cheaper, off the shelf Wi-Fi router like this one. This is a travel router. It is provided by GLINet, right? This is the model number, and there are a lot of these devices in this range. You can even find better ones. This also supports 11 AC, right? On 2.4 gigahertz band, it supports two streams. On 5 gigahertz, it only supports one stream, right? And so that's the hardware part, right? So once you have the hardware, after that, you can actually look at the software side. So what you can actually do, if you have to go down, this access point route, you can find a OpenWRT compatible device. OpenWRT is a very popular, router operating system. It's well maintained. It is well supported by the community. Currently, it supports up to 1,200 devices. You can actually go on their site, uh, and you can actually find a list of supported hardware. Right? They support hardware of different shape and sizes, right? Of different capacities. For example, there is this. Yeah. So if you search for GL, you'll actually find that they have a lot of hardware from GLINet, right? All of these you can see, right? If you click on it, it will actually show you more details on it. Similarly, if you want to go for more, powerful ones, you can search for Ubiquiti. So Ubiquiti hardware is, even more better than this and more expensive than this. So for example, this one here, right? If I search for it, Unify AP Pro, you'll actually find that this is the device. This is a device that you can buy, from a store, or you can buy it online, right? But again, it will be a little bit more expensive, right? However, what you can observe here is it is a dual radio 3x3 11 AC MIMO technology, right? So you can actually uh, install, you can actually flash it with your custom OpenWRT firmware, and you can use it as a sniffer, right? So if you create something like this, you will be able to face the high throughput environments also. But as if you are starting in Wi-Fi, I will not really suggest you to go for such a high-end device, because it is, there are chances that when you are making changes to it, you might end up breaking this. Breaking means you were trying to flash the firmware on it, you made some mistake, now it is in a state where you cannot recover it easily, right? So it is not booting up, right? Or if it is booting, it is not properly booting, it is just stuck in some loop or something. So that state is called breaking, right? You cannot use it anymore. So even if you want to do experiments, go for a cheaper one like this, which is easily recoverable if something goes wrong. Or if you want to try it, and if you are completely new in this field, go for the USB cards for now. This information is so that you know that there is a possibility to go beyond the Wi-Fi, USB cards, right? It is just to expand your horizons. I'm not asking you to go for a high-end device as of now, right? It is just when you know about it, you know about it, right? Then you can explore, you can think more on it, and then eventually one day when needed, you will know what to do. So now, next thing that we have to talk about, right? So we are talking about sniffing setup. We have talked about the hardware. If you want to go for 2.4 gigahertz sniffing, if you are going for lower stream 5 gigahertz sniffing, then you can go for USB cards, right? If you want to go for a more powerful environment, if you are targeting a 11 AC Wave 2 8 cross 8 device, then you can go for a Wi-Fi access point, which is modified, right? That is the hardware part. Second, if you are using the USB, what is the software that you need? You need a Kali VM, right? we already discussed that. You can download it, you can use it. If you are using a Wi-Fi access point, you should go for OpenWRT, right? Because that is easy to install, that is easy to configure. It has a package management system also, right? So just like in Ubuntu, you can do apt get install vim or apt get install something. Just like that, in OpenWRT, you have OPKG. So you can use OPKG and you can install the wireless tools. You can use the tcpdump, tshark, and whatnot, right? So that's why the OpenWRT is a recommended one. So we have covered hardware, the platform, right, and the software. The third thing that we have to talk about is the antennas, because antennas can help you uh, capture the traffic or attack a specific network from a distance also, right? So there are generally two kind of antennas. You can divide them in two kind of antennas. One is the omnidirectional one. These are the common ones, and as I mentioned before, right, they send the signal in a oval kind of shape, right? It's not a perfect sphere, but more of a oval kind of thing. But they are spreading the signal all around, right? So thing is, if you want to use it for your home, it's kind of good because you are getting signal all the sides. But due to this, the range is limited, right? And you will get a spread of the signal all around, right? However, if you want to attack or if you want to capture traffic from a distance, right, you need range. And you can get that range by using a directional antenna. So what a directional antenna does is, instead of spreading the signal all around, it will focus the signal in a specific direction, and hence the word directional, right? So what will happen when you are using a directional antenna, you will be able to pick up the traffic, from a farther distance. Uh, and this is an example of a directional antenna that you can get from Amazon. It's a 11 dBi high gain antenna, which actually works for 3G, 4G, and Wi-Fi also, right? So with an antenna like this, in line of sight, if you want to suppose if you want to sniff a traffic from a office or from a company which is like 1 kilometer far from you, or half a mile from your place, you can go onto your rooftop, you can point this thing towards them, and you might be able to pick the traffic from it, right? Again, it totally depends on the kind of interference there is, right? What kind of obstructions are there, right? The if there are power lines in your proximity, right? Your Wi-Fi or any other wireless propagation technologies like your 3G, 4G, right? All of them, they are affected by a lot of factors, right? So it is very difficult to quote the exact numbers, but the idea here is, if you have a high gain directional antenna, you can even be sitting 1 mile from the place, and you still be able to send packets to it and receive packets from it, right? So this is the setup that you can use to perform sniffing, right? Now let's talk about some basic terminology, and we will also take a look at how you can perform sniffing on a basic setup, right? So don't worry about it. Basic terminology that we are going to use throughout this boot camp. Uh, these are some terms. So BSS stands for Basic Service Set, right? It's a set of nodes that are communicating with each other. Most of the cases, it is going to be access point and clients. Then comes BSS ID. BSS ID is the identifier for this BSS, and it is the MAC of the access point that you are using, right? Then come the station MAC, right? Station is any wireless client that you might be using. It can be your phone, it can be your laptop, right? It can be some other device. Uh, so station MAC is the MAC address of the wireless client. Then comes ESS. ESS stands for Extended Service Set. Uh, One or more BSS, they form a ESS, right? So at least one BSS or more, they can collectively form a ESS, and ESS is identified by ESS ID or the SSID, right? So this is what we see in the network name. So you have your Wi-Fi networks. Wi-Fi networks has names, right? Right, your like your home network, your corporate network, right? Uh, or depending on your vendor name, right? You can configure them. So that is the SSID. Name of the Wi-Fi network is the SSID. This ESS or your Wi-Fi network, it can contain multiple access points, right? So each access point, we will refer it uh, as a BSS, this and the clients connected to it. The MAC of the access point will be BSS ID, and the MAC of the clients will be station MAC. All right. So this is example of a BSS. So you can see this is a access point. BSS ID is the MAC of this guy, and then you have devices connected to it. Then you have another BSS here, which is using another access point, and obviously the MAC is going to be different here. But the SSID is actually the same, right? So this is the SSID. This is the Wi-Fi network name. And because it is the same ESS, a device can actually move from this BSS to this BSS easily, because again, it is all part of same ESS, right? So that's the basic terminology. Now let's talk about Wi-Fi frame basics, right? So just like when you transmit data over the LAN, what you do is you are transmitting some IP packets, right? IP packets are encapsulating uh, the UDP or TCP type in them. In that you have application data, right? Like the HTTP data or something. Uh, and this IP packet is then enclosed in a Ethernet frame. And that Ethernet frame is transmitted on the from one machine to other machine, right? In similar manner, when you want to transmit something over Wi-Fi on or wireless LAN, you use WLAN frame for that, right? So WLAN frame is there, and in the WLAN frame, you will have the data that you want to transmit. So this is a typical frame, right? This part here, right, that you are seeing from frame control to QoS, it's called the WLAN frame header. Then you have the frame body, right? So if you're transmitting a IPv4 packet, that IPv4 packet is going to be in this, right? It is going to be inside the frame body. And then you have FCS or frame check sequence, right? It is more of a checksum just to make sure that the frame that you have received is not corrupted, right? It's the checksum. So let's take a look at the frame header. But before that, when you capture the Wi-Fi traffic and you open it in Wireshark, right? This is how your WLAN frame actually looks like. So here it's a broadcast frame, as you can see. Uh, you will see all the details like this here. Then you will see the radio tap header. Radio tap header is added by the device that actually captures this traffic, right? So if you have captured this frame, this Wi-Fi frame using a Wi-Fi adapter, the Wi-Fi adapter is going to create a radio tap header. The radio tap header will contain the information about the capture, right? Like the timestamp, the frequency on which it was captured, the data rate on which it was captured, and this header is added to the frame and it is saved in the PCAP file. Why? Because this information can come handy when you are analyzing the traffic, right? That's why it is added. It is not part of your, so this part and this part, right? This part is just interpretation of Wireshark. So Wireshark is showing you this information. It's more of a metadata kind of thing. It's not part of the WLAN frame. Similarly, radio tap header is also not part of the WLAN frame. It is something that is created by the capture device or capture interface, and it is saved so that when the analyst, whoever is analyzing the data traffic or the Wi-Fi traffic that we have captured, can use it to understand more about this, right? So after this, you have your radio information, right? This again tells you about the physical medium, right? You can see it is using 11B, right? You can see the data rate, the channel, the frequency. After that, you actually get to WLAN header. So now this is from where your real WLAN frame, which is actually transmitted, is present, right? Again, it is the logical part, right? When we really transmit it, there are a lot more complications, right? But you don't have to get into all of those as of now. We will cover them whenever needed. So this is your WLAN header. In the WLAN header, you can see a lot of fields, and we are going to go through these fields one by one so that you understand, what they mean, and then you can perform Wi-Fi traffic analysis on your own. But just to show you, because again, a lot of people miss this and they make mistakes when they are, they don't, understand why this radio information is there, what is radio tab header, and why this information is being shown. So it is not clear to most people that this radio tab header is actually added by the capture device. It is not part of WLAN frame. So this is the WLAN header, and then if we talk about the WLAN header has different fields here. First and most important field here is the frame control. The frame control is a 2 byte long field, as you can observe here. If you expand it, right, you can actually divide it into these bits, right? So 2 bytes means 16 bits, right? So 16 bits are used to represent a lot of information. First 2 bits here will represent the protocol. Next 2 will represent the type of the frame. Next 4 will represent the subtype. Then comes 2DS, from DS, more frags, retry, power management, more data, protected frames, and order, right? Now, all of these frames are not very important from security point of view, right? But we will cover the important ones. And what I'll suggest is, when you are, and I'll provide you some Wi-Fi captures also. When you will go through it, try to read about these frames more on your own also. And if you think that something is not clear, just let me know and I'll explain it again to you. So first field here is the protocol. The value of this protocol field will always be 0, right? So this is kind of the value for the Wi-Fi as of now. If this field contains anything except 0, that is not technically Wi-Fi then, right? It is some other protocol then. So they have only used value 0 for now. Maybe in future they might want to create versions or something, and they might then put value 1, 2, 3 or something here. But for now it is just 0. So for now you can just ignore this field. Not really important, right? Then comes the second part, and this is very important. There are different kind of frames in Wi-Fi, right? Because in Wi-Fi it is complicated. It is more complicated to do everything in a wireless manner, right? So you have different types and subtypes of frames. Uh, there are 3 types of frames of Wi-Fi. First one is the management frames. Management frames, they are to manage the discovery, advertisement, the connection and disconnection of the Wi-Fi devices, right? The second type is control frames. These control frames actually facilitate the delivery of your management and data frames, right? And then the third type is the data frame. And it is obviously the most important frame, because all of this, right? All the things, all the protocol, right? The different standards that we are using, all of this is done to ultimately transmit data between devices, right? That's the whole objective. So management and control frames are there to facilitate everything, but data frames are the main frames that are actually carrying the data that we want to transmit between the devices. So these 2 bits that you have here, they represent the type of the frame, right? So if you have 00 in them, it means it's the management frame. If you have 01 here, it means it's control frame. If you have 10 here, it means it's a data frame, right? And 11 is reserved for now. Similarly, you have a subtype also. So when you open this WLAN header, right, in this, you can see the interpretation here. This is the frame control field, right? This is the version. As I was telling you, it will be 0 always. Then the type is here. You can see 2 bits are used to represent the type, right? Uh, this is 0 or 00 in the bits, which means it's a management frame, right? And then the next 4 bits are going to represent the subtype. And in this case, subtype is 8, which means it's a beacon frame, but you don't worry about it. We are going to cover this also. So this is a table of subtype and type. Here you can observe all of these with value 00 are management frames. And you can see the subtype here, right? These are the 4 bits that will represent the subtype. You have association request, response, reassociation request, response, probe request, probe response. This one is reserved, and this is not just one. There are multiple in this case. Uh, Beacon frame is there, this association, authentication, deauthentication, right? And even action frame is there. Then for 01, you have control frames. And then for 20, you have the data frames, right? 10, it means 2, right? 01 means 1 in decimal, right? This representation obviously is in binary. So these are the subtypes. Now it's not really important to remember everything here, but the main frames you have to remember, because those will be important to understand what is happening, right? And I'll highlight those. So when your Wi-Fi client is connecting to a Wi-Fi network, right? SSID. When it is trying to connect to a SSID, what is the sequence of packets, right? What is the flow of packets? That's what we are trying to see here. So here we are assuming the simplest setup, right? You have a SSID, which is using open authentication. It does not have any encryption, right? No security settings. It's the open network that we see at airports and all, right? So first of all, the advertisement is there. Advertisement is done by beacon frames. Beacon frames are the frames that actually are to tell other devices in the vicinity that this specific network is operating here. And these are the parameters. These are the properties of this specific Wi-Fi network, and you can connect to it. So this is the screenshot of your Wireshark, where we have opened a a beacon frame. So you can tell from this WLAN packet header that it's a management frame. The subtype is 8, right? In this also, you can tell the receiver address, the destination address, the transmitter address, source address, the BSS ID, right? All of this information is available in the WLAN header of all the packets. Uh, when you open the remaining part of it, right, you will actually see these entries. These elements are called information elements, or IEs, right? And in these you can find different informations. So for example, you have SSID. So name of this network is moonbucks_Wi-Fi. It is using channel 6, right? And then there are supported rates that, okay, this specific network can support all of these rates, right? Data rates. And then there are other factors. So beacon frames are used to advertise to all the devices in the vicinity. These are sent by the access point, and these are sent at a very high frequency. So when I say frequency, I means a lot of packets are sent, a lot of frames are broadcasted. In general, you will actually see there are around 6 beacon frames, or 10 actually. Yeah, it was, I think, 6. There are 6 beacon frames, and it is totally customizable. You can actually change, but in most cases, by default, around 6 frames are sent per second. So when your devices, right, your phone, your laptop, uh, it gets the beacon frames, it will parse it, and it will show you it in your network list, right? So you turn on your Wi-Fi, and then suddenly you see that, okay, these Wi-Fi networks are available. So this information is shown to you after your device parses the beacon frames and shows you the network list. Similarly, one more way of finding the network is using probe request. Probe requests are to find a network to which the device it had connected in the past. So suppose today you have connected to one device. What your device will do, uh, it will then keep looking for this network again. Whenever it will find that network, it will actually try to join it automatically. That's how your automatic connections actually work, right? So when you walk into a place where you have connected to the network in the past, your phone will automatically go ahead and connect to it, right? So because it is always looking for it. So in probe request, the device, as you can observe here, the subtype is 4, right? It's a management frame. What it does in this case is, uh, in most cases, your probe request, it is broadcast, right? Broadcast frame. It either defines the name of the SSID that it is looking for, or it can also define the wildcard SSID, right? So when it says wildcard SSID, it is not defining any SSID here. It is looking for any network that is available. If it defines a name here, then it is looking for that specific Wi-Fi network. So these probe requests, right? So these are broadcast. They will go into air, and your Wi-Fi access points, right, which are in the vicinity, they will actually get these probe requests. And if this probe request is a wildcard probe request, or if it is mentioning the SSID that is hosted on that specific access point, then the probe response is sent back. Then access point actually reaches back, right, and it tells to this guy that, okay, I am hosting this specific SSID. Please reach out to me, right? And the same thing you can see here. This probe request was sent by this device, right? It was a broadcast packet, right? And it was looking for a wildcard. And this access point, which is hosting Moonbug's Wi-Fi, actually replied with a probe response. And in the probe response, it also again tells about its SSID, the supported rates, the channel, and all the other info, right? Similarly, we also have a authentication packet, right? Uh, it's just authentication packet, but we sometimes refer it to as authentication request. This is the packet that is sent by your client to your access point when it wants to connect to it. And in this case, you can see it's a open system based authentication, and the sequence number is 1. Now, one important thing to remember here is the name of this packet or name of this frame is authentication, but it has nothing to do with your conventional authentication. It is not checking the credentials of other party. It is not performing any kind of check against some database or some pre-known secret. It's not doing that. It's not doing the conventional way we perform authentication. It's not doing that. It is just making sure that the other device also speaks Wi-Fi, right? So it is just validating it. It is not performing the authentication in the conventional way. So when device sends this authentication packet to the access point, the access point also responds back with the same packet, but in this case, the sequence is 2 instead of 1, right? And that's why we actually refer it as a response. Otherwise, the type of the subframe is always authentication, Right? It's not authentication response for a request. Once the authentication packets are exchanged, after that, when the device wants to connect, right, they actually exchange association request and response. Again, they just exchange some information in it, right? Nothing to do with authentication or anything. So this is the association response packet. Similarly, when the device wants to disconnect from an access point, right, or an access point wants to kick the device, they use disassociation packet, or they can also use deauthentication packets, right? And if we have to take a look at the full flow, once the advertisement is done by the beacon frame, right? Or if the device is looking for a specific SSID, so suppose it is looking for home SSID, so it will send a broadcast probe request looking for home SSID, right? Uh, if the access point is in the vicinity, it is supposed to respond, right? Because that is how the Wi-Fi standard is. This guy has to respond with the probe response. So it is going to tell this guy that, okay, I am here and I am on this and this channel, right? So once the device gets this surety that okay, this network is here, this is the BSSID. After that, it actually sends the first authentication packet. This first authentication packet will reach the access point. The access point will then send the authentication response, and then the device will send association request, right? And then access point will send the association response, and after this much, they can then start exchanging the data. So then they can start transmitting the data in any direction they want. And because it's the open authentication network, right, there is no encryption, so there is no additional step. They are directly sending traffic to each other, and anyone with a monitor mode interface can actually see what kind of traffic they are sending to each other, right? Coming back to here, the next part of your WLAN packet header tells us about the direction of the packet or the frame, right? So the frame direction is shown from this. So if you're here, it is important to understand what DS is. DS means distribution system. Distribution system refers to the main network, right? So when I say main network, it is the network that is actually providing you the backbone. If we are talking about a Wi-Fi access point, it is the LAN network that we refer as DS, right? So if to DS and from DS is both zero, it means it's not your BSSID based system, right? It is more of a ad hoc based network. In that case, you will find it as 00. If your 2DS is 0 and from DS is 1, then it is exiting the DS, which means it is coming from the access point to the client. If it is the opposite, if 2DS is 1 and from DS is 0, it means it is going from the client to the access point. If both of these are 1, 1, then it's a special case. It means it is in a wireless distribution system. Now, what is wireless distribution system, right? So if we take a look at this diagram here, it will become clearer to you. So this is the basic scenario, right? You have your Wi-Fi access point. It is connected to a LAN, and we are considering this part as the distribution system, right? And then this guy is creating this network. Again, we have used circles to show the coverage. So now this guy is creating this Wi-Fi network, right? And this guy is using it from here. It is connected to this guy using Wi-Fi, right? Now problem is, because the range of this access point is this much, but we have a client here, right? This access point cannot serve this client here, right? And the problem is, for some reason, we cannot give a LAN connection, a wired LAN connection to this guy here, right? So what we can do in that case is we can form a wireless distribution system. How wireless distribution system can be formed? Uh, you cannot give this access point a wired connection, but you can always create a wireless link between this access point and this access point, which is connected to LAN, right? So this link here, this link between this access point and this access point is called WDS, right? It is the wireless distribution system. So what will happen now, this access point has a backlink. So now it can create its own network and it can connect to this client, right? So what will happen when your Wi-Fi frame is traveling in the WDS, you will see an anomaly like this, right? One. Would Netgear, Orbi, etc. be considered as example of WDS? Okay, I'm not sure about which one you are talking, but I think you are referring to the ones that that are now in the market, where you have three of these access points. You can deploy them in different rooms, and then it will cover your whole house, right? Is that what you're referring to? That's the wireless mesh technology. It's yeah. Yes. You can actually. So there is a slight difference. Uh, some of them they use wireless mesh technology, and some of them they use WDS, right? So there is a slight difference between these two, but yes, on a bigger scale, you can actually say it's a WDS. Yeah. Wi-Fi mesh. That's what I was saying. So Wi-Fi mesh is one way of creating a WDS. So yes, you can actually say that. Similarly, when you are going through the WLAN packet header, you will come across these four addresses, right? Uh, Now there are four addresses because you will need them in some cases. In some cases, it's not necessary that destination address and the receiver address is same, right? It is not always possible, especially when we are dealing with WDSs. So that's the reason why you have four addresses instead of two addresses in Wi-Fi, right? Then you also have BSSID, in the field in the packets, right? And BSSID field will use one of the addresses from this. It totally depends on the type of subtype of the frames, which addresses will be present in it. There you can see, this is the BSSID, right? Which means the MAC of your access point, right? Then you can see the receiver address and the destination address. In this case, these are same. Similarly, transmitter address and source address are also the same because of this specific frame. But there are cases where you can have different receiver address and destination address and different transmitter address and source address. And that's the reason why you are given four fields instead of two fields. And then the most important part is the frame body, right? So you can observe here, this is a data packet, right? In the data packet, you can see 802.11 data, right? And if you open it, if you are dealing with open Wi-Fi network, right, all of this is not encrypted. The data packets are not encrypted. So you can actually see the upper layer protocols, right? So you can here clearly see that it's a ARP packet in the frame, right? And then in the end, you have FCS or frame check sequence. Frame check sequence, as I was mentioning before, it's the checksum that actually makes sure that the packet that you have received is not damaged, is not corrupted. So now let's talk about sniffing Wi-Fi traffic, right? There are two settings. One is the local sniffing and the other one is the remote sniffing. Local sniffing means you have a machine with you, you have attached your Wi-Fi card to that machine, and now you are using Wireshark, T-Shark, tcpdump, or some other tool to perform sniffing on that machine, right? It is showing you Wi-Fi traffic on the same machine to which you have connected the Wi-Fi adapter, right? The other setting is remote sniffing, in which you are working on one machine, but you are using a remote machine. You have connected the Wi-Fi card to that remote machine, and you're capturing on that machine, and you're getting all the packets on your machine that is with you over the network, and that's called remote sniffing. So let's take a look at how we will perform Wi-Fi traffic sniffing using a Kali GUI VM. So here we can observe that we have already attached our card to it, right? So in this case, I have attached two cards, uh, two USB interfaces, two USB cards, right? Uh, First one is mounted as WLAN 0, the other one is mounted as WLAN 1, right? So now what we can do here is to list them. We have used iwdev command. And again, no need to make notes of these commands. I have already added slides for these. I will pass the slides to you, and you can take it from there. These videos will also be shared with you, right? Okay, yeah. So in this case, these are emulated cards. These are not the real cards, but I actually use TP-Link cards that I have mentioned in the links. Then what we are doing now, we are putting one of the card into the monitor mode, because you need to put them in monitor mode when you want to perform the sniffing. So you can use iwdev command. You can define the interface, that is WLAN1. Set monitor none is the command. Again, no need to really remember the commands. You can create a cheat sheet from the PDF, so for some commands, and for the others, it's always easy to check the help, right? So iwdev is the main command. You can check the help for this, and from there you can create your own commands. So now if we check the interfaces again, you will observe that here the type was managed, but now the type has changed to monitor, right? Yeah, you can also use Airmon for it. But what we have observed is that Airmon actually creates problems sometimes. So Airmon used to work, pretty good if we talk about, 3-4 years back. But now I have seen that a lot of cases, Airmon actually creates problem. So it actually helps if you are directly using this utility. It's very stable. It does not create any problems or interferences, right? So you can also do the same using iwdev, or you can also use Airmon. It's totally dependent on you. If it works on your setup, it's okay. There is no, do you have to use check kill with IW? Uh, if your card is being used, yes, you will have to. But if it is not being used in anything, then obviously you won't have to. So the Airmon check kill command used to check if there is some process that is using your Wi-Fi adapter. If it is, it used to kill it, right? And that used to help a lot. If you're not sure, why it is happening. So yes, you still have to do that if you are using this command. So here we can observe that it was in managed mode before. Once we set it into monitor mode, the type changed to monitor, right? But still it's not up. So we have to turn this interface up by using ifconfig wlan1 up. We can do that. Once it is up, we can again list the devices, and what you will observe now is here it was not showing any channel details, right? It was not showing any TX power. TX power is transmission power, right? So here, after turning it up, we can see that it is on channel 1. This is the center frequency. The width is 20 megahertz, right? This is again, right? You can see center frequency is this. So now your card is ready. You can use it to sniff the traffic. And now we are opening another tab. And here in this tab, what we are going to do is we are going to run Wireshark. Once you run the Wireshark, Wireshark will show all the interfaces that are there. It will also show WLAN 1 interface that's in monitor mode, and you can select it and you can open it. It will then show all the packets that it is receiving on this specific interface, right? So you can see it is seeing the SSID evil cop. That's the only SSID it is seeing, right? And you have to understand here that currently our card is on channel 1, right? It is not jumping on any other channel, uh, because it can only listen on one at a given time, right? So when you are listening using the Wireshark, when you are listing all the packets, you can also do the same using other tools like tcpdump, right? And you can also do the same using aerodump. Now, thing with aerodump is when you will run aerodump like this, aerodump will automatically start making your interface jump, right? See here, right? This channel is actually changing, right? Why? Because aerodump is changing the channel of your interface automatically. It is doing this because it wants to jump on all the channels to find the details about the networks and the, the devices that are in the vicinity, and it wants to show you a summary, right? That's why it is doing it. And that's how you can monitor, both bands or multiple channels uh, using the same card. But essentially, it is jumping on the channels, right? It is not looking at all the channels at the same time. It cannot do that. So now, because it is jumping, it was able to even find another ESS ID, that is evilcop2, right? And because the channel was jumping, if you are, if you were seeing this traffic in Wireshark, you will also see the traffic from WLAN, from this evilcop2, right? So if you want aerodump to stay on at one channel, you can define it, right? You can say -C1, and it will then stay on channel 1. It won't jump, right? So you can see here, it's not jumping anymore. And then if you want to save it, you can stop the capture, and then you can also save this pcap, right? Using the Wireshark or any other tool that you like. And this traffic is with you now. You can then select the packets, and and you can analyze it. So yeah, that's what I wanted to show. What drivers does IWDev uses, right? So it depends from system to system, but when you are using your WLAN cards on Linux machines, most of the times Netlink drivers are being used. Netlink, right? So most of your Linux machines, they actually use that. So these are some basic commands that we use to interact. Yes, 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 yes. It's like NL. It's I'll post the exact name, but it is, I think, NL Mac 802.11. So these are the basic commands that you can use to interact with the Wi-Fi interface once you attach it to your VM, right? So first of all, uh, no, I don't think it is RTL. I think it is the Netlink one. That's different one. I'll find the exact name and post it here. It starts with NL. So as far as I can remember, it's that. Yeah, actually, yeah. I think this is the one. The Mac 802.11 is the one. Yeah, I'll confirm on it, but I think mostly it is the one. So LS-USB command can be used to view all the USB devices that are attached to the machine, right? So when you do LS-USB, you will actually find a list of these devices, and from there you can tell if your Wi-Fi card is properly, attached to the machine or not. Once it is attached, again you can use IWDev to list all the Wi-Fi interfaces. You can also do the same using IWconfig, right? So when you do IWconfig, you will be able to see all the Wi-Fi devices. If you want to see more details about Wi-Fi device, you can use IWPHY command. It will show us the information about the capabilities of the device. So for example, this thing here, right? It is very important. If you're not sure that your card that you're using supports monitor mode, you just use IWPHY. It will give you an output like this. In this, you will find a section like this, right? The supported interface modes. Just make sure that monitor mode is here, right? If the monitor mode is not present here, your device does not have capability of using monitor mode. Similarly, it will also show you all the other informations like, the channel width that it supports, right? The bit rate, the frequencies, right? As you can see here, this card, it supports all the 14 channels. Similarly, for if it is also capable of 5 gigahertz, it will also show the same list for 5 gigahertz, right? You can observe here, it is telling us that it has support for 160, the channel with width of 160 megahertz. And this is how you can check for regulatory domain. So I was telling you about the regulatory domains, right? Regulatory domains govern how your device is going to behave. If it is going to work on all the channels, or if it is going to, allow you to transmit more than a specified power, right? All of that depends on the regulatory domain. You can check the regulatory domain of your device using IWREG-GET, right? It will show you that. So here you can see it's set to Japan, right? Uh, and all of this information it is showing, because the if you have set it to Japan, Japan will actually, the Japan country's regulatory domain will actually allow you to use the channel 14 also, right? It will allow you uh, to go beyond a specific TX power, right? Similarly, if you want to change it, right? So for example, suppose I want to set it to US, right? So I can set it to US, and then if I check the regulatory domain, you will actually see that okay, it's now changed, and you won't be able to use channel 14 anymore, right? So this is how you can check and change the regulatory domain. Uh, you can also use IWDev command to set the channel. So you can use this command, and it will change the channel. When you do this, it is setting the channel width to 20 megahertz, because that is the default, right? If you want to go for 40 megahertz, you have to actually define it like this, right? So when you do HT40 plus, it means it is going to use a 40 megahertz width channel, right? Now again, this is also very important. So when you do 40 plus, right, 40 plus means it will use the channel 6, and then it will form bonding towards the bigger channel, which means this is the center frequency for your channel 6. But when you create the width, so it's very important here, when you had width of channel as 20 megahertz, right, the center frequency of your channel 6 and the center frequency here are the same, right? 2347, 2347. Width is 20 megahertz. However, when you do HT40 plus, in that case, you will see that the center width for channel 6 is still 2437, but the center here has been shifted to 2447. Why? Because we don't have a width of 20 megahertz anymore, right? We have a width of 40 megahertz. Similarly, if you use HT40 minus, then the binding or the bonding will be done towards the backside. So what will happen? Your center will actually shift to the other side. So that's what you can see here, right? The channel 6 here, the center is 2437, because we have used 40 minus, right? The width is still 40 megahertz, but your center is moved towards the 2427, right? Behind this, right? before this. So this is important. Similarly, you can also set it to 80 megahertz, obviously only for the channels of your 5 gigahertz, because 80 megahertz is not supported on your 2.4 megahertz, right? So similarly, you can also do 160 if it is allowed on your device. Now you can ask me, why do we need to set HT40 plus, right? Is it really necessary, right? Why do we need to set a channel width to 80 megahertz? So it is important to understand that your frames, right? Your frames can use different channel widths to to be transmitted. So for example, your management frames, like your beacon frames, and it is very, very, very important, right? When you are performing traffic sniffing on a scenario or a network, Wi-Fi network, where channel bonding is done, in that case, you have to make sure that you are able to see the data traffic. So when the channel bonding is done, in that case, the management frames will still be transmitted on the 20 megahertz, right? Because you want the management frames to be available to all the devices, right? So you will be able to see the beacon frames. Doesn't really matter if you are using 20 megahertz channel or 40 megahertz. But if you are on 20 megahertz channel, and if the channel bonding of a 40 megahertz is done, right? If the data, if your channel, if your Wi-Fi network is using channel bonding, and if it is using a 40 megahertz channel, right? And you can tell that, by taking a look at the beacon frame, you can tell that by taking a look at the app that I described, right, in the very beginning, the Wi-Fi analyzer. So once that is clear, if your device and your access point, right, if they both have that capability, they can start using 40 megahertz to transmit the data packets, because that will give them higher throughput, right? They will be able to transmit more by using a 40 megahertz channel. Now the problem with that is, if you are on a 20 megahertz channel, right, you still be able to see the beacon frames, the probe responses, the probe request, and all of that, but you won't be able to see the data packets or the data frames. Why? Because those are being transmitted on 40 megahertz channel, and you are only looking at 20 megahertz, right? So that's the problem. That's the reason why you have to make sure that you are using appropriate width to, you know, to make sure that you are able to see the data frames also. A lot of people make this mistake. They are targeting a 11 AC network, and they are seeing the devices, they are seeing the access point, but they are not seeing any data traffic, right? And they then think that, okay, for some reason, this setup is odd, they are not transmitting any data frames, but they totally overlook this fact that the data frame might be going on a wider channel and they are not able to see it, right? So please don't make that mistake. We have already covered this. To turn your device up and down, you can use IP link set or ifconfig command. Now, if you have connected your device on your machine, and if it is in managed mode, you can still use it to scan for the Wi-Fi networks. You can use iwdev, the name of the interface, and you can issue the scan command. What this command will do, it will actually show you the details of all the networks that are available in the vicinity, right? But it is going to show you all of these details like this, right? So if you just want to see the SSIDs, you can just put a grep in front of it, and it will then only show you the SSIDs, right? Similarly, if you want to connect to an open SSID using the command line interface, you can use iwconfig wlan1 ESSID and the name of the network. And what will happen? Your card, right, your interface will then connect to it. And this is how it looks. It will tell you that, okay, it is connected to AngelNet, the type is managed, and this is the channel on which it is currently, right? So we have already gone through this. AP client connection flow, right? I'll quickly go through this one. So it's the packet walkthrough. A fake auth attack is something different, right? So we'll talk about it later. Don't worry about it. So currently we are just understanding how your devices actually work, what kind of packets they exchange when they are connecting to each other, right? So whenever you are performing, traffic analysis for Wi-Fi traffic, try to start from this place here in the Wireshark, go to wireless, select the WLAN traffic, and when you do, it will actually show you this table. The benefit of this table is that you will be able to, get a quick overview of what networks are there, right? How many packets or how many frames of different types are there, right? How many beacons are there? How many data packets are there? What's the name of the SSID? What's the BSSID? How many clients are connected to it, right? All of that you will be able to see quickly. So it is advisable to start from here. So for example, here, by just taking a look at it, I can tell that the BSSID is this, SSID is this, and this guy here, right, this client, it seems that it is exchanging most of the traffic with this BSSID, right? So that's a very good thing when you are trying to do the Wi-Fi traffic analysis. It saves time if you're focusing at the right thing. So now we already know that, okay, this is these are the stats, right? Data packets, probe requests, probe responses, and this is the client, right? So what I'm doing now, I'm actually applying a filter on basis of this, right? This is a WLAN address based filter. So when I applied this, I'm making sure that I'm only seeing those frames which contain this specific address. So I can see a lot of frames here. If we go up, we can see the probe requests and probe responses, right? And then there are a lot of other packets also, or frame also, right? Like the control frames. So we don't want control frames here, right? So in that case, what you can do, you can right click on it. Okay, so the question is, can we use wildcards in Wireshark filters? I don't think so. I have to check actually. I have never faced this question before, but I don't think we can actually use it. I'll check and let you know. I have never used wildcard, before, because there are other ways of doing the same effect, but I have not tried star. I don't think it will accept star, but I'll check and let you know. So what you can do is you can filter out the frames that you don't want, right? So you can just right click on the frame, apply as a filter, and you can select it. I'm using and not selected because I don't want to remove this. If I just use not selected, it will actually overwrite the previously available filter here. I want this filter to be there, and then I also want the newly added filter to be there, right? That's why I'm using this and option here. So once you do that, it will automatically take all the action frames, control frames out, right? And then we have your probe requests and all the other frames. So now here you can see the full flow. First, this is the client, this is the access point. So your client is sending authentication packet to the access point, right? You can see this is your packet header. You can see the subtype and type. You can also observe the BSSID. And then here you can observe the authentication sequence is 1, right? This is the first packet that is being sent. Now, if you check the next packet, this is again the same subtype 11 authentication packet. However, it is being sent by the access point in response to the first packet. That's why the sequence number here is 2, right? So again, there is no conventional authentication that we are doing in these packets. We are just making sure that both devices they speak Wi-Fi, right? And then you have your association request. Now, association requests are there to exchange some information about each other, right? So you can see the network information is being exchanged. And once the association request is accepted or is received by the access point also sends the association responses. And once that is done, the data exchange actually starts after this, right? So you can observe after that, if you select the next frame, that's the data frame. And one more way, when you are dealing with open networks, right? So this capture that we have here, it is from open SSID. There is no encryption. So all the inner layers, all the inner protocol layers will be visible. So in that case, if you want to quickly see what kind of traffic you have, right? If you want to see an overview, you can go to statistics and then you can select the protocol hierarchy. When you do this, it will actually show you analysis, and we can clearly see that, okay, we have a lot of packets of IPv4. And in that, if we see, we have most of these packets in TCP, right? TCP. And then we have HTTP packets, and we also have then other packets, right? So this quickly helps us in to find out, right, what kind of packets and what kind of traffic we do have. So now when we have selected this one, it looks like a DHCP packet, right? But if you take a look here, it has a radio tap header, it has radio information, it has a WLAN header also, right? So it's a data packet. But because it is not encrypted, because it belongs to an open SSID, we are able to see inside it. When I say we means us and the Wireshark. And that's why Wireshark is able to parse the payload of this WLAN data frame. And it is telling us that inside this, it has a IPv4 packet. It's a UDP and it's for DHCP, right? Similarly, if we apply filter for HTTP, right? Here we are applying filter for HTTP, then it will only show us HTTP traffic. Again, you can observe it's a 802.11 data packet. Inside that you have IPv4, inside that you have TCP, and then inside that you have HTTP, right? So this is how you can actually analyze your open Wi-Fi traffic. I am going to share this PCAP with you, so please feel free to analyze it, right? And try to use different filters and see if you can, find information out from this. Now coming to AeroDump. So AeroDump is a very famous tool that you use for performing recon on Wi-Fi networks. When you run AeroDump like this, right? So you use the AeroDump ng command. You define the network interface on which you want to run it. And then what it will do, as we have already seen in the example, the demo, it will start making this interface jump on different channels, and it will then show you a table, a summary table of all the BSSIDs, SSIDs, right? All of their other characteristics and the clients that are available in the vicinity to you, right? It is so that you can quickly see what all is there. It will also show you the devices and the PNL. Devices are the one, devices are the non-station, devices are the stations, the Wi-Fi stations, right? Now, Wi-Fi stations can be connected to your Wi-Fi network, or they can be just roaming, right? Roaming means they are not connected to any network, but they are there. Now, because of the probe requests, right? Some of these devices who are doing active probing, Active probing means they are sending out probe requests. So what AeroDump can do, AeroDump can parse these probe requests, and it can show you all the networks that a specific device is probing for or looking for. So this list here, it's called the preferred network list for this device, or PNL, right? Because these are the network to which this specific device wants to connect, right? That's why it's called PNL. Okay. Will there be any cheat sheet available with all the commands you are showing us? So I don't really believe in cheat sheets. What I believe in, I'll actually give you all the slides, right? Uh, I believe in remembering few of the commands and then to know where to look for, right? Because there are so many commands. Remembering them might not work always, but it totally depends on you. If you want a cheat list, I can provide you a cheat list. That's not an issue, right? But once you know which are the basic commands, right, you can then build on top of those. You can check their helps, you can check their manual pages and create. But please let me know if you want a cheat sheet. I'll create one and give it to you. That's not an issue. Now, when you run AeroDump, right, by default, it is only going to run on 2.4 gigahertz. If you want it to run on both the bands, you have to mention this part here, right? So you have to say band ABG. ABG means it is going to listen on both 2.4 and 5 gigahertz. Okay. I'll share the cheat sheet with you guys also, right? So here you will observe that in addition to your 2.4 gigahertz channel, you are also able to see the channels from 5 gigahertz, right? Now, what's the fundamental problem with the open networks? Fundamental problem is your client cannot authenticate the access point, right? Uh, the SSID is the only thing that it can use to decide, if the network is right or not. And anyone who has the same SSID on his network can then, lure the client into connecting to him, right? And that is how your honeypot-based attacks work on airports and all, right? Because on airport you have so many open network that are officially hosted by the airports. Even if you create a honeypot, right, the legitimate users won't even know if it is a real network or a fake network. So what are the basic attacks that we can do with the knowledge that we currently have, right? We are going to discuss about the secure networks, we are going to discuss about a lot of attacks, but the information that we have learned today, we can still do some attacks with this. So what are those attacks? First attack is the Wi-Fi honeypot attack. We can use our setup and we can use softwares to create a fake Wi-Fi network, uh, which can then be used to lure the clients in, right? How we can do that? Uh, for first way is we can do it ourselves, or we can use some automated scripts and tools, right? So we also have labs on these, right? So I have also mentioned the labs. For a few, I have also mentioned the GitHub link. You can, clone it on your machine and you can run it. Uh, so how do we create the Wi-Fi network, right? That is the question here. There are two ways of doing it, two popular ways, I will say, right? Apart from these automated scripts, automated tools, there are two basic or fundamental ways of doing it. First one is to use Airbase. Airbase is a part of Aircrack NG suite. It is the same suite, which actually contains your AeroDump. So Aircrack NG suite is going to be a very big part of whatever we do with Wi-Fi, right? Cracking, sniffing, replaying packets, right? All of that. It contains multiple tools that will help us in performing that, and we will talk about those in detail. Airbase NG is also a part of Aircrack NG. It actually is used to create fake access points, right? So you can use Airbase NG. You can define the card that you want to use. You can define the parameters, and it will create a fake Wi-Fi network for you. Another tool that you can use is called Host APD. Host APD is also used to create the Wi-Fi networks. We will prefer Host APD because Airbase NG has a lot of limitations. Airbase NG was created just to do the attacks, right? So it had very limited options, very skewed implementation. Whereas Host APD was created to be used as a real, Wi-Fi access point software. It is used by a lot of enterprise companies. It is used by a lot of customer grade Wi-Fi access points to create the Wi-Fi networks, right? So it is way more stable. It is way more versatile. That's why we will go with HostAPD. It actually allows you uh, to to customize your network, up to any degree that you want. It is really good when you want to run your network for longer durations of periods, right? Longevity testing, right? So that's why we will go with HostAPD. But feel free to explore Airbase also. So how you can create a open Wi-Fi network? You have to use HostAPD configuration, right? This is the configuration. Uh, you define the interface first, then you define the driver that you are using. Uh, if you are using a Linux machine, this is the driver that is used in most cases. NL802.11, Netlink 802.11. This is what I was referring to at that time. Uh, so I have also seen this being used and also seen Mac 802.11 being used on OpenWRT. So, right, but most of the cases, if you use NL, it will actually work. Then you define the SSID. That's the name of the network that you want to keep. If you also want to specify the MAC address for your Wi-Fi network, right, the BSSID, you can also define that. And you can also define the channel. Yeah, so this is something that you have to, search around. So for most of the Linux system, it is going to be the Netlink driver. If you are using something else, so do we set up NL in the same way? No, you don't actually have to set it up. It will be in most cases it will be the part of your Linux machine already. That's the beauty of it. For Modpub, you have to do a lot of things in most cases. So you don't have to do that in Netlink. So you define the channel. Once you have created this configuration file, right, you name it open.conf. Frankly, you can name it anything that you like. Just I have used it open.conf. So it is more complicated than just using a command to confirm it. Uh, you have to actually look into some more details to find if it is using NL 802.11. This much you can even figure out from the documentation itself. So even if you search for it, you will actually find the documentation that actually talks about how Linux is using it, right, and all of that. So everything, Linux documentation. So Kali is just a flavor, right? Everything is provided by the Linux. So if you just search for NL 802.11, and I will also post some links to it, links about it, which you can then use to find more about it. So once you have created the configuration file, after that you can use this command, right? HostAPD needs to be installed on a Linux machine. You can directly do apt get install HostAPD or yum install HostAPD. It will be installed. And when you run this command, it will actually create an access point with this name, right? And this BSSID that we have defined on the specified channel. So after doing this, if you check this network on your mobile phone or maybe on your laptop, you will actually see this network, right? So a quick demo of creating it. We have gone beyond the planned time. but I was expecting it because first time when we are building the basics, it actually takes time in the theory. Uh, so here we have these two interfaces. We are writing the configuration file. It is exactly the same configuration file that is there in the slides. I have just pasted it here. And then you can use hostapd. You can use the configuration file name and you run it. And there you go. Now your access point is enabled and you can actually verify the same by using IWDEV, right? So you can observe on WLAN 1, you have evil SSID operating, right? On channel 6, the type is AP now, right? When you are doing monitor mode sniffing, the type is monitor. When you are using this card to connect to another network, the type is managed, right? So check this, whenever you find that your card is not working properly, please make sure that it is in the correct mode. Now what we are trying to do here is we are trying to bring the WLAN 0 up, and we will try to connect to this network using WLAN 0. So once you have brought it up, if we list it, we'll actually see that it can now scan for the networks. Because it's a virtual lab, right? This video is from our own lab. I only have one network that is present in the vicinity. That's why it is only showing me one network. And then I can use the iwconfig command to connect to this network, right? So iwconfig WLAN0 ESSID and the name of the network. That is evil SSID. And when I do this, this interface will now connect to it. So there you go. It is connected in managed mode to SSID, evil SSID, right? So this one. Uh, so this is how you can create and connect to an open Wi-Fi network. Now, please remember, when you are doing this, you are only creating the Wi-Fi layer connectivity as of now, right? To really exchange the traffic, you also need IP address, right? So what you have to do is, once you do the first step, you also have to run a DHCP server on it, so that any real client, if it comes and connects to your Wi-Fi network, it should be able to get the DNS configuration and the IP address from your honeypot, and then it can exchange traffic with you, right? So a lot of people again make this mistake. They just create the Wi-Fi point and then they expect the client to come and connect and exchange traffic. But if the IP layer connectivity is not there, he won't be able to do it. So if you are creating a honeypot, just make sure you're also running a DHCP server on it. Or the easier way of doing it is to use BetterCap or EepHammer or something. They actually will take care of all of this for you. So that was this. Now, what all other attacks we can do with this information that we currently have? So first attack is a nuisance-based attack that's called beacon flood. What you can do in beacon flood is uh, you can create multiple fake networks to confuse and irritate people, right? So suppose you take your phone out, right? You want to connect to a Wi-Fi network and you are seeing something like this, right? You can tell by looking at it that, okay, these are not legitimate networks, but there are so many of these networks that it has pushed the legitimate network down in this list, or it has just made sure that the list does not have space for the legitimate network. So it is not causing any real damage, but it is causing some nuisance. So it is called beacon flood attack. You can perform it with this tool called MDK4. So what MDK4 does when we are running beacon flood with it, right? We have a lab on it also, so you can check the lab out. Uh, so when we run this, it is actually creating fake beacons, and we have already learned about beacons now, right? We know that beacons are used to advertise Wi-Fi network. So if you are sending fake beacons, a lot of them, right? Uh, what will happen? The devices in the vicinity, right? They will think that okay, it's a real network, and it will start showing it on your device, and you will see something like this, right? So again, very easy to execute and a very simple attack. Similarly, second attack, which will again create denial of service and nuisance, is the deauthentication attack. So if you remember, I was telling you that deauthentication frames are sent by one device to other device when the other device wants to disconnect, right? So suppose a laptop is connected to a Wi-Fi access point. Now the laptop wants to go, right? It wants to disconnect. So what it does, it before leaving, it actually sends a deauthentication packet to the access point, and access point will then delete all the records for this specific device. It will drop the state that it is maintaining for this device, right? It is done to make sure that the efficiency of the whole system can be brought up, right? So because these access points, they have limited resources, right? If the device is going away, there's no reason why it should store the packets for it, why it should maintain the state for it. So that's why these packets were there. But thing is, when this deauthentication packet is sent, right, there is no way till WPA2, there is no way uh, for the receiver to know if this specific frame is sent by the legitimate device or not. So by leveraging this fact, one can create fake deauthentication packets, which are which looks like that they are coming from some other device, but they are not. And using those devices, you can actually force a client to disconnect from other client. Why? Because it's part of Wi-Fi protocol, right? It was part of it. The deauthentication packets were for this reason, but they never thought maybe at that point of time uh, that someone is going to spoof them in the future, and then it is going to be a issue. So in this case, you can use another tool from aircrack ng, that is air replay ng. You use -0 to define the deauthentication. Then you define the number of packets that you want to send, right? 100. You can even select a higher number if you like. And after that, you define the BSS ID you want to target. And after that, you have to define the interface that is in monitor mode. So when you do this, it will start sending deauthentication packets or frames like this. And this will make sure that all the clients that are connected to this specific BSS ID will disconnect from this BSS ID, right? This is how it causes nuisance. If you only want to disconnect a specific client, you can use -C, and you can define the MAC address of that client here. And then that client will again, will be disconnected. And if you keep sending these packets, right? If you again, make this number as 10,000, or maybe even more than that, then that device will connect, disconnect, connect, disconnect, connect, disconnect again and again and again, right? Causing the nuisance. So again, uh, we know about the basic Wi-Fi packet analysis now, right? So by taking the packet dump in Wireshark, we can actually find the SSID, right? We can find the clients. We can analyze the open SSID traffic, right? This much we have covered. Uh, if we are using Wireshark, can we automate all of this? Can we create a Wireshark plugin which will actually, do this analysis for us? So yes, we can actually. We have worked on such a open source tool a few years back actually. It's called PA Toolkits. It is available on GitHub, right? You can check it out. And we have also given, I think, this video recording was done for a workshop for DEF CON last year. So you guys can watch it if you want to know more about Wireshark plugins and how you can write one to analyze the traffic from a security point of view, right? So you can check it out. Uh, we can perform recon because we know how to use aerodump engine now. We can find clients and access points. By taking a look at the MAC, we can also tell about the manufacturers. And once you know about the manufacturers, once you know more about the devices, you can try to find the specific vulnerabilities, right? You can do that. Uh, Attacks, we have learned about the beacon attack, the deauthentication attack, the fake captive portal attack, and one more attack that we can perform is we can try to attack the browser. So what is the fake captive portal attack, right? So it's more of a social engineering plus Wi-Fi network attack, right? So what you can do in this case is you can create a fake SSID. Fake SSID means fake network, right? You can use hostpd for that. We have already learned that. uh, Run DHCP server on it. Very easy to do, right? Just need a few configurations and a DHCP server installed, right? Once that is done, host a fake page, just like we do in your mail phishing, right? You host a page, right, which looks like a real page, and then you you make the target user enter some kind of information in that. So in similar manner, you can host a page like this. Suppose you are in a coffee shop, you can create a fake page quickly, right? You can create a form where they can enter their phone number, their password or something, right? And then you can create this hotspot there. As soon as they connect to this, they will see this page, they will enter the information, and you will get the information, right? Social engineering, captive portal attack. So if you want to do this, you can also take a look at this social engineering toolkit. I'm sure that most of you guys have already used it. If you are trying to do this captive portal attack using a modified Wi-Fi router, you can use no-dog splash. If you're using Kali, you can use SET. If you want to do this attack using your phone, here's a article that you can go through and see how people have done it. Again, all of the information that I'm giving, and sharing with you is for educational purposes. I hope you guys are not going to use it, for offensive, motives. Similarly, you can extend this same attack, the fake honeypot attack, into attacking the browsers. But it will only work in some scenarios, as you can tell. So instead of using the SET, what you can do is you can serve a page to the user, and in that page you can actually embed some of the exploits that work on the browsers. So if the user who is visiting the page that you have hosted on your fake honeypot, right, on your fake Wi-Fi network, uh, if he's using an outdated browser, he might fell for it. His browser might get exploited, and you might get shell on his machine. Another way of doing this is you can actually perform JS hooking. So once the user is connected to your honeypot, right? If he's exchanging traffic with internet using your honeypot, you are actually seeing his traffic, right? So you can use something like this beef project, right, to insert the JavaScript hook into his HTTP traffic. As soon as this page loads on his machine, you can then run some attacks on his machine also, right? Like you can give him pop-ups, right? You can run other things. You can see what he is trying to open, what he's trying to do. You can try to prank him, right? All of those things you can do. So you can check the beef project and you will know. Uh, so now when we talk about the open networks, right, there is no real security, but there are some pseudo security measures that people have used to keep their networks a little bit more secure. One way was the hidden SSID. So in hidden SSID, your beacon frame, right, the SSID field of the beacon frame is actually empty, right? So there is no SSID advertised. So only those clients who already know the name of the network can only connect to it, right? So this was used as a pseudo security measure, but it is very easy to beat this, and that is actually the lab assignment that you guys are going to do, how to figure out the hidden SSID. Similarly, another pseudo security measure was to implement MAC filtering. So, you have a Wi-Fi access point. Uh, you will maintain a table of allowed or whitelisted Macs, and any other device which does not match this table won't be able to connect, right? That was the MAC filtering. But again, you can actually bypass this by changing the MAC. So that is also a part of your assignment. So these are the lab assignments that you have to do, right? You go to attackdefense.com. If you face any difficulty with the lab, just let me know, just DM me or just post in the live instructor interaction channel. The idea is you will try to do these labs, before the next class. So you are ready and you have covered all of this part, right? So we can move to the next stage. In addition to the lab assignment, here are some assignment questions for you to think about, right? For you to explore. Uh, if you are able to do this, that's really great. If you are not able to do this due to your work engagement, due to your busy schedule, that's also totally fine. We don't really expect you to take a lot of more time out and do these. So what we do is, in the next session, before starting the planned activity and planned topics, we actually discuss this assignment, right? So it doesn't really matter if you do it or not, you are anyway going to learn. That we make sure of, right? So these are the assignments that you have to do before next session. Now, if you have any questions, you guys can ask that, and then we can conclude today's session. If you have any questions, just write them in the live instructor interaction, and we can take care of those. Today's session, we actually took one extra hour because of all the explaining, right? I'm very uh, hopeful that all of this information is going to help you in building a better base. And once you have the better foundation, we can make a, okay. Can I ask? Yeah, yeah, sure, 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 Mike. You can ask anything that you like. That's totally fine. So during the session, I try to avoid the questions which are not, related to the session. But after the session, you can ask anything that you like, because our first target is to cover whatever is planned, right? A lot of people are there, so don't want to waste anyone's time. Apart from that, just please feel free to ask anything that you like to, related to topic, related to Wi-Fi, anything on the Discord. I can take it offline, right? So we are not wasting others' time. But there are no restrictions on asking questions. You can ask whatever you like. Okay, so you are asking about WEP. I think you are asking about WEP attack, right? Yes, Vinayak, you can also do that. I will actually share. So you have already gotten a mail from my side, right? The instructions for Wi-Fi bootcamp mail, right? So yeah, please send that. That's my own mail, so you can actually send email on that to me. Yes, WEP. So Mike, we are going to cover it in next session, but just to answer your question, we don't really know which ARP packet we are replaying in that case. What we do is we just trying to uh, find packets that looks to be ARP packets, that seems to be ARP packets, and then yeah, totally, trial and error. We just replay it, and if we get a response back, we know it's the right one. And then we will, keep doing it again and again and again till the time we have enough packets. For others, guys, this is something related to WEP that we are going to cover in the next session. So don't worry if you're not able to relate to it. We are anyway going to cover it in complete detail. Yeah. We can totally create one and give it to you. I'll make a note of it for the cheat sheet and also for the checklist methodology. And yes, we can totally do that. So before the bootcamp ends, I will actually share these two things with you. You are most welcome. So guys, if you have any more questions, please ask. And also, please feel free to ask questions anytime you like, right? Uh, okay, so I think we have run out of questions for now. I will share the slides with you. The recording of this session will be shared with you within next 12 hours. So you guys can go through, both of these. You can play some labs on attack defense, especially the labs that I have mentioned in the assignment section. So once you do that, I'm very sure that there will be questions. Please feel free to ask them before the next session or in the next session, totally up to you. So with that, uh, okay, so I think Vinayak is typing. Let's see if he has some question. Okay, yeah, he stopped typing. So, okay, I think the question is not there. Okay, guys, thank you for attending the first session, and thank you for being the part of our fifth iteration of Wi-Fi pen testing bootcamp. I'll see you in the next class. And in the meantime, if you face any difficulties, please let me know on the Discord server. And yeah, okay, guys, bye bye.